like turtles.
Gotta have them ribs.
Welcome to We Sing Dinosaurs. Deinonychus lived in the early Cretaceous period, after Allosaurus and before Tyrannosaurus rex.
One of the most fearsome hunters wasn't big at all. He measured close to 10 feet long and only 5 feet tall. Deinonychus, with his powerful jaw. Deinonychus, with his terrible claws. When they spied a likely foe, they'd race to the attack.
I actually really like this song.
With his powerful jaw, Deinonychus, with his terrible
This song
claws. His arms were long to hold his prey, sharp claws were used to grip. But the deadly claw was on his foot, the one he used to rip. Deinonychus, with his powerful jaw. Deinonychus, with his terrible claw. He wasn't a big dinosaur, but Will was bound to say he must have been the very fierce hunter on the shore. Deinonychus, with his powerful jaw. Deinonychus,
Well, hello everybody, and welcome back to Paleontologizing. It's good to see everybody here today on Wednesday, August 26th, 2026. We're going to have a fun stream. This is going to be most likely our last stream until probably next Tuesday. Just want to say that off the bat. I've got a wedding to go to over the weekend. My good friend Ethan is getting married, head of the Central Laramidia Project, the Mesozoic Research Center. You know him, you love him, Ethan Cowgill from Utah. He's getting hitched, and I'm really excited for him. He and his fiancée, Lauren, are tying the knot. So I'm going to Utah, leaving first thing tomorrow morning to, go celebrate with them. I'm excited. But it does mean that we're going to be missing a few days of stream. It's going to be a busy autumn. There's a lot of stuff like that going on this fall. So I'm going to be missing some streams for sure, but it'll be worth it. I've been looking forward to this. What part of Utah? Salt Lake City. Yeah. We're going to be up in the mountains near Salt Lake. It's going to be a lot of fun. And I'm really looking forward to seeing a bunch of friends and colleagues there. It's going to be excellent.
The planet was clumped together in one vast supercontinent.
And Don Vito,
Dinosaurs soon occupied every corner of that world.
thank you for the 4 months of support. Really appreciate that. Thanks for keeping me here online. Excellent. We've got a sub goal going for today to try and raise a little extra money. It is not going to be cheap to drive all the way to Utah and back, and the hotels and everything. Also, I'm going as cheap as I can with this, but you know how these things go. So anyway, and Little Pig Bunny says, look at Danny getting new shirts. Yeah, this one I've had for a good while now. I just haven't worn it on stream. But, yeah, trying to look sharp for you, chat. Anyway, if it's anyone's very first time here, where are my manners? Let me introduce myself real quick. My name is Danny Anduza. I'm a dinosaur paleontologist. I'm here on Twitch trying to do some good old-fashioned science outreach. So whether it's broadcasting live to you from my office here in the San Francisco Bay Area, going over new scientific papers as they come out, interviewing other paleontologists remotely, doing 3D printing and looking at videos online about fossils and all of that. The whole point is to try and give you an inside peek into how paleontology really works. During the summers, and I'll be going back out again, I guess, end of September, I broadcast live from the field. So from live dinosaur digs, from excavations out in the wilds of Utah and Wyoming, and this year Montana too, and maybe some other states next year as well. Like I said, the whole point is to not just tell you, but show you how paleontology works. From excavation, to fossil prep, to study in the lab, to publication. And then all the outreach afterward, too. We've got exciting stuff coming up. We've had a lot of exciting stuff already this year. It's just exciting stuff all around. So I'm glad you're here. On today's stream, we will actually be doing final assembly of our Diabloceratops skull 3D print. Didn't really have time for this yesterday. So I've got a life-size 3D print of this critter right here, Diabloceratops. We'll be talking about why it's so special, and then I'll at some point yank the Protoceratops off the wall, and we'll put Diablo on there once it's assembled. We'll probably do that earlier on in the stream today. I want to get that part done. We've also got Metazoa, we've got Q&A, all that good stuff. Speaking of Q&A, especially if you're new here, if you happen to have any questions about paleontology, the study of fossils, if you have questions about the fossil record, about the history of life on Earth, if you have questions about dinosaurs in particular, which are what I actually work on, or if you have questions about broader topics in fossil science, questions about extinction, evolution, the origins of biodiversity, questions about the very nature and process of science itself, please do not hesitate with those questions. That's kind of the bread and butter of our streams here. That's what makes things special. As a live broadcast, we've got this this chat window right over here. Type your questions right in and I'll do my very best to answer them for you. It's what separates this from like a pre-recorded and edited lecture or something. It's interactive, you know? And I find things to be a lot of fun when folks are engaging and, you know, we can have a conversation. So anyway, welcome to Paleontologizing. We're gonna have a fun stream today. So yeah. And I appreciate that, Tree Antichrist. My weekend is all booked up. But thank you. I appreciate the offer. Really looking forward to being back in Utah for a little bit. I spend a lot of time there. Nearly a month there so far this year. All told, it'll be about a month and a half total, 2026. But yeah, appreciate that. Thank you. And thank you, Lukai. I'm glad you like the shirt. Yeah. Little Pink Pony says, in my brain you wear the uniform even off stream? This isn't a uniform, these are just my normal clothes. I try and put on like a collared shirt when I'm streaming. It's a sign of, I don't know, respect. I'm trying to take things seriously without being too formal. But, you know, often off stream I wear, you know, t-shirt. I print a lot of my own t-shirts. So yeah, I don't know. Can I find a picture? Let's see. Oh, this is me at the Monterey Bay Aquarium last week. I don't know. Yeah, this is how I dress. I guess a lot of that is kind of a result of the fieldwork that I do. A lot of that carries over into my everyday garb, I guess, but yeah. Yeah. Let's see who else is here in the chat. Golganak, I believe, was first today. Howdy, Golganak. I hope you're doing well, as always. Good to see you. Science streams, Balint. It was a privilege to be able to raid into your stream yesterday. I hope you had an excellent rest of your broadcast. Thanks for doing what you do. We've got Savar, we've got Give Them Nell, we've got Go for Fluffernut, we've got Dr. Terminator and Dark Muppeteer, Fake 2D, NX Jara, Murph Swerf, Mothproof KT, Taxstar, Danish Viking, Squiggles de Gabo, Kulfungaren, Kanto Arcade is back, hello. Palosaurus says bonjour, right back at you, Palosaurus. Welcome. Scoobs has returned. Charlie's Dragon, thank you for everything that you do, Charlie's Dragon. Good to see you as always. Twitchy Nose Rabbit and Apri. Tolkien Otaku. Little Pink Pony. Taxdu. And Lukai Spark Electronics. Hope you're doing well too. Good to see ya. And Mikey Likes and It Then Did. Diplotomodon has returned. Welcome back, Diplotomodon. With another Tyrannosaur emote. Excellent. Just like your namesake. Hello, hello, everybody. Yeah. Good stuff. Before I forget, let's do a Blue Sky post. Also before too many people show up and we get and the chat fills up too much. I could do better than that, screenshot-wise. Let's try that. There we go, that'll work. Yeah, nice. There we are. Let people know that we're live.
Let's protect our fossils, because if they're removed, America loses them forever.
Holy cow. Thank you, Sunny Blue, for subscribing. Really appreciate that. That's a recurring sub right there. Thank you for that pledge of ongoing support. Thank you for helping make science outreach on Twitch not just possible, but helping it thrive. Thank you for that. Appreciate it. So today's paleontology stream.
Observation. You couldn't see a thing. Conclusion. Dinosaurs.
Thank you, a son of Sobek, for the 3 months of support. Our favorite Egyptian crocodilian deity. Thank you, son of Sobek, for the 3 months of support. Really appreciate that. Welcome back. And Anert says, what is your favorite dinosaur yourself? I'm not a dinosaur, but I don't have, I got rid of my Twitter, or at least stopped posting there because the website's just a cesspool nowadays. So I switched to Blue Sky, and I've been so much happier there. So that's where we're at. I guess I didn't delete my Twitter because I don't want there to be like an impersonator snagging my username. But Blue Sky is where it's at nowadays. It's especially true for scientists. Science Twitter is kind of dead. Just about all of the scientists that I know who post to Twitter have moved to Blue Sky, and it's a heck of a lot better. So what do you? Yeah. Till next Tuesday. Join us for fossil science discussion and final assembly of a life-size 3D printed Diabloceratops skull at twitch.tv/paleontologizing. It's good. On the wall behind me are life-sized 3D prints of a diplodocid sauropod femur, a Protoceratops skull, a Deinonychus skull. I almost forgot. We should talk a little bit about Deinonychus today, if we have time. Given that the anniversary of Deinonychus's discovery. You'll see why I put that in quotation marks in a little bit. Another fossil science miscellanea looks good. Let's post it.
Hold on to your butts.
There we go. Looks good. Here is a link to that post right here. I'd like to engage with that for whatever reason. But yeah. Yeah. And Twishy Nose Rabbit says, isn't your favorite dinosaur actually Archelon? No, Archelon's not a dinosaur. And it's not really a... Archelon is cool, but I don't really have like a strong personal connection to that critter. I've never worked on any Archelon fossils. I've never, yeah, I don't know. Archelon's cool. But it's... never considered my favorite critter or anything close to that. I do have a project coming up, though, where I'm going to be looking... Oh, by the way, Archelon, for anybody who's unaware, is an enormous protostegid turtle from the late Cretaceous of North America. I think South Dakota may be where it was from, where it was discovered originally. Yeah, so that's the relative sizes of Archelon compared to a large protostega compared to Dermachelys coriacea, the modern leatherback turtle. It's not known whether Archelon and the other protostegids are close relatives of the modern leatherback, or whether they're a completely different radiation of turtles. That's something that I would love to help figure out. And I have a project that I'm kicking off. I've kind of begun work on it, but really need to jump into it in earnest. I'm trying to figure this out. How close are these guys to the Dermacheliids, like the modern leatherback? Sole surviving member of its lineage. It's a big question, and nobody really knows. And yeah, we'll be talking more about this in the coming weeks, because as September starts, I'm going to be getting ready to go do some field work. Not fossil field work, but field work here, not too far from where I live. Off the west coast of San Francisco. I'm going to be looking for leatherback turtles. With NOAA and with the nonprofit Upwell Turtles. We're going to be tracking leatherbacks, taking them on board the vessel, collecting data, measurements, attaching transmitters to them, all that good stuff. Really excited about that. It'll be with this group. There we go. So anyway, leatherback turtles have been something of an obsession of mine for the past year. Incredible animals.
Many people aren't aware in California that we have these giant prehistoric animals that routinely visit our waters. Leatherbacks arriving off the coast of California are birthed in distant nesting beaches in the western Pacific. But eventually, when they get large enough and can withstand the cooler temperatures off the coast of California, they'll come here to feed on jellyfish.
So it's the voice of, I almost called him George Upwell. That's George Schillinger, who is the, I think, executive director and founder of Upwell Turtles, which is a local nonprofit. They raise funds and contribute that to the conservation and study of leatherback turtles and other marine turtles in California and across the Pacific and around the world. There we go.
About leatherbacks, jellyfish populations would boom. They begin to consume massive amounts of forage fish and smaller fish and the larvae of really commercially important species. So leatherbacks play a really important role in the ocean ecosystems they inhabit. I'm George Schillinger. I'm the executive director and co-founder of Upwell Turtles. Our mission is to protect and conserve leatherbacks and other marine turtles in their at-sea habitats. So Upwell's been working with NOAA for the past 2 years to support NOAA's aerial.
And Hectagon says, I think they were supposed to exist in Florida but got lost. No, leatherbacks have a cosmopolitan distribution. So they literally live all over the world. The ones off the coast of California are part of the Pacific metapopulation. They swim all the way across the Pacific Ocean. There's other populations around the world. There's a few in the Atlantic. There's one in the Indian Ocean. But they have, like I said, a worldwide distribution. So, there's a map. Everything that's this bluish color is where leatherbacks can be found. Pretty extraordinary. They've got the widest distribution of any non-avian reptile in the world. It's one of their many, many superlatives. In fact, they might have a wider distribution than any bird species, too. But yeah, pretty extraordinary. Yeah. They've been observed swimming as far north as the Aleutian Islands off Alaska, or Iceland up here in the North Sea. In fact, that's Iceland there, right? This should encompass Iceland. They've been photographed swimming in between icebergs. And then as far south as like nearly down to Tierra del Fuego, Tasmania, the southern island of New Zealand. Incredible animals, you know? Dog Among Kings wanted to know, do dinosaurs use the current two-part Latin naming structure? They do. Yeah. No, that's the funny thing is that with dinosaurs, well, the one that everybody's heard of that uses both parts of the binomial is, of course, there we go. T-Rex. All dinosaurs have this kind of structure to their name because this is what we call a scientific name, a Latin, it's not always Latin, but a binomial. So there's the genus and the species. Tyrannosaurus is the genus name and Rex is the species. All dinosaurs have this if they've been scientifically described. So I'll show you. People often only refer to dinosaurs by their genus name. But, here, Allosaurus. Allosaurus fragilis is, well, fragilis is one species of Allosaurus. Coelophysis boweri. Boweri is the species, Coelophysis is the genus. I think Boweri is the only species within genus Coelophysis. Most dinosaurs are like this, where they only have one species within each genus. Although there might be more than one species of Barosaurus. But yeah. So, Albertosaurus libratus. There's also Albertosaurus sarcophagus. Actually, this might be Gorgosaurus libratus now. Struthiomimus altus. Ornitholistes hermani. Oviraptor Phyloceratops. Microvenator, Celer, Saurornithoides mongoliensis, etc. Deinonychus enteropus. We'll be talking about this dinosaur a fair bit today, I suspect. Yeah. And yeah, Psittacosaurus has the most species named in it of any dinosaur genus. Any non-avian dinosaur genus, I guess, man. Wugga wugga, but yeah. And Hector Hectagon says, is that like how cats are categorized as felines? So, not quite. You're on the right track, but that's a little broader. I'll explain. So what we're talking about here is zoological taxonomy. So... There we go. We'll take a fox as an example. So, this is the red fox. Vulpes vulpes. This is kind of a funny one because the genus and species names are the same. But anyway. Vulpes is the genus, and then within that genus there are several species. The red fox is Vulpes vulpes. So the genus is Vulpes. The family is Canidae. The order is Carnivora. It is a mammal, so it's class Mammalia up here. If you do that with a cat... Here, we'll use a lion as an example here. That'll work. There we go. So the lion is Panthera leo. Panthera is the genus. Leo is the species. So the species is Leo, the lion. Within genus Panthera, you've got a bunch of different cats. Lions, tigers, leopards, cheetahs, jaguars. And then within that, so this genus, Panthera, is within the family Felidae. So that's all these guys plus more. Things like bobcats, things like domestic cats, things like ocelots. They are all family Felidae. And then you move up into the order Carnivora. And then there's a bunch of different mammals that some of them eat meat, some of them don't. This doesn't necessarily mean that they're all carnivores in terms of their diet, but yeah. This part's actually wrong. All animals that feed on flesh only. There are carnivores that don't. Like pandas don't only feed on meat. They mostly eat bamboo. Same with things like raccoons. They don't just eat meat, nor do bears. Bears eat berries and roots and garbage and all kinds of stuff. Anyway, and so you can keep moving up and up and up until eventually you get to all life on Earth. And we'll be talking about this today like we do on every stream, pretty much. All life on our planet can be represented by a big family tree because every living thing on our planet, from bacteria to quinoa to ladybugs to kelp to octopus to you and me, we're all part of one gigantic family. We all evolved from one single common ancestor. It's really beautiful when you think about it, that all life on Earth is related. We as human beings share at least some portion of our DNA with every other living thing on planet Earth, including bacteria, including bugs, including bears and bats, especially bears and bats. We share a lot of DNA with them because we're both mammals. So the closer you get, the more DNA you're going to have in common. So if we jump down to the mammals, all of these critters have a lot of features in common. They all feed their young with milk. Most of them have fur or hair. Most of them are warm-blooded. And that's because they all evolved from a single common ancestor. Something that would have looked kind of like, something that would have looked kind of like this. A little Morganucodon, or Morganucodon, tomato potato. Does that make sense? Yeah. Oh, and you're right. You're totally right. Sorry, cheetahs are not Panthera. That diagram was wrong. Cheetahs are genus Asionyx. So where was that? There we go. Yeah, cheetahs are not actually genus Panthera. That's wrong. Maybe that's supposed to be a leopard or something? I don't know. It looks more like a cheetah. Again, this diagram's not perfect. But anyway, as you get broader and broader and broader, you're encompassing a wider variety of different creatures, and yes, that does include plants. Plants are part of this too, Spark Electronics. So if we go up to all life, plants also have DNA. They also have cells. They also have a lot in common with animals. But there is a split between animals and plants. A couple of billion years ago, I think. Here's the plants. Yeah, about 1.8 billion years ago, they all had a common ancestor. So we can link that here. Let's see when plants and animals last had a common ancestor. Plants and animals. There we go. Yeah, about 2.1 billion years ago. So the eukaryotic organisms, the creatures that evolved to have a nucleus in their cells, this, right when you have the dawn of the eukaryotes, that's when plants and animals split and started evolving in their separate directions, if that makes sense. Moosey Fate says, "Oh, animals, you." Right back at you, Moosey Fate. Good to see you again. Welcome, welcome. Yeah. So pretty neat that, like, literally all of life on Earth is related. So I'm going to zoom back out to the origins of life, and you'll see this is where plants and animals split right here. But for about 2 billion years, they were the same thing. Since the dawn of life up until that split, that's about 2 billion years, give or take. Maybe 1.5 billion. But the common ancestor of all the eukaryotes, the common ancestor of animals and plants, would have looked, you know, something like this. A little one-celled organism. It's only after that split takes place that things get more and more and more complex, if that makes sense. Having multiple cells, and those multiple cells forming different structures just added layers of complexity. Does that make sense? Yeah. And Spark Electronics says, plants and animals divided so late, considering how life exists on Earth. Yeah, it's for like well over 1 billion years. Life on Earth was just single-celled organisms. It's sometimes referred to as the boring billion. Yeah. Otherwise known as the Mid-Proterozoic and Earth's Middle Ages, is an informal geological time period between 1.8 and 0.8 billion years ago, characterized by slow biological evolution. Yeah. Oh, hang on. No, so eukaryotes may have evolved around the beginning of the boring billion. Okay, never mind. After eukaryotes evolved, they still kind of stayed mostly single-celled. So, yeah, I think it's basically right here, single-celled life. No. Anyway, I'm not going to get too into the weeds with this right now, but thank you for the link there, Charlie's Dragon. I was just about to post that. Yeah. Anyhow, good stuff. Trick Trek says, who needs more than one cell, you know? Some critters are just a little extra like that, you know? The majority of organisms on our planet are single-celled. Yeah. Here we go. Prokaryotic versus eukaryotic organism. Oh man, that did not end big in the way I was hoping. Anyway, yeah. But yeah. And there you go, Smitty One Werbin. Yes, indeed, it is any more, Cody. Good ears. Yeah. Anyway, where were we? Let's talk a little bit more about leatherbacks. This might be the plane that I'll be working alongside. Again, fingers crossed that all of this works out and the weather holds and I get to do this. This will be between September 9th and 12th. But they use a spotting plane to actually locate the leatherback.
Years to support NOAA's aerial monitoring surveys. and their boat-based work, which involves surveys for leatherbacks, examination of leatherback habitat, and the capture and tagging, both with satellite tags and camera tags of leatherbacks. What the NOAA surveys have shown through the satellite tracking was they've revealed these extensive migration routes. They've indicated high-use habitats where leatherbacks go to forage, and then they've helped us pinpoint interactions with fisheries and where they may be most likely to occur. COVID-19 has posed some real challenges for our team this year. We're looking for creative ways to still conduct the monitoring work, and we've been considering unmanned aerial surveys using.
So that apparently didn't work. They tried using drones as like a last resort sort of thing, and it was a big failure. So they've gone back to, as I understand it, actual manned aircraft.
Drones to follow along the same track lines that are used by the aerial surveys and to fill in the gaps. And we're hoping to obviously sustain this work for as long as possible. And in the interest of conserving this species and ensuring its place in the ocean for years to come.
Anyway, cool stuff. So this is one of the things I'll be doing in just a few weeks, and I cannot wait. Holy cow. We'll be doing some special streams centered around leatherback turtles in the time leading up to it. That's gonna be good stuff. But yeah. And exactly, Charlie's Dragon, yeah. I'm gonna do my best to share that with you to the best of my ability. And folks like Spartan help make this possible through their contributions. Thank you, Spartan. Look, we're now less than a ninth, more than a ninth of the way to our goal for today. Thank you, Spartan. We've got a 10 lucky chatters, so I'm sure just as excited as this Tinamou bird. What happened? Oh, Tinamou error. Thank you, Spartan, for your generosity there. I really appreciate it. Holy cow. Good stuff. Anyhow. Yeah. And they go Spartan, yeah. Eukaryotic cells. You prefer multi-cell rather than single-celled? It seems you also prefer multi-sub. Thank you for your generosity, Spartan. I really appreciate that. It's gonna be pricey for me to drive all the way to Utah tomorrow. Thank you for helping make that possible. Yeah. If anybody else is feeling really generous, there's an item that I could really use. Here we go, for the leatherback field work. If you want me to be able to share that with you afterward, then really use one of these. This is not a GoPro. It's like 1/5 the price or something like that. It's a knockoff, but it's very well reviewed. And if we want to be able to get good footage of these leatherbacks so that I can share that on stream, this is on the Amazon wish list there. If anybody's feeling really generous. Because I'd love to be able to share that with you, but it'd be great to get some underwater footage. I think that would be so rad. Yeah. And thank you, the Scuttler, for the follow. Thanks for dropping in. Thank you, the Scuttler. Excellent. Yeah. Anyhow. And everyone needs Prime subs if you got them, says Drunky Kong. It's good advice.
At no expense.
And Claire Burr, you did not have to do that. Thank you for gifting Drunky Kong.
Claire gifted a tier 1 sub to
I appreciate that, Claire.
DINKEYKONGLON.
I appreciate that very much.
157 gift subs.
Holy cow, Claire. You did not have to do that. Thank you for that. I really appreciate it. And thank you, Chudley, for the 101 bits. Lovely. For... Thank you, Chudley. Good stuff. Yeah. Yeah. And Twitchy Nose Rabbit says, I was just on eBay looking for Archelon fossil pieces. Oh boy. Archelon's not a common turtle, so that is really unlikely. Looks like the people selling the pieces did not know exactly which prehistoric turtle they belonged to. Would you be able to tell from the carapace texture pattern? That's the thing about Archelon is, thank you, Flickster, for the 200 bits. Really appreciate that. Thank you, Flickster.
Smiley face.
Yeah, that's the thing about Archelon is it, hang on, Mikey likes.
Playing tag with you, Iguanodon.
Thank you for those 100 bits there. Really appreciate that, Mikey. Thank you kindly. Sweetie Pie, you're shaking the camera. Hey, stop. You're pushing the auxiliary camera into the main camera. That's not great. It's not great, sweetie. It's not. Look. Don't mess up my... What's stuck to your tail? You got some plant... You got some vegetative matter stuck to your tail. Were you out on the catio? Of course you were. That's the thing about Archelon is it doesn't have a carapace. It doesn't. Huh, Sweetie Pie? She's pushing the camera around again. Come on, Sweetie Pie. Hey. Hey. Oh. So it's not going to be Archelon material if there is a carapace, because Archelon doesn't have that. It's just got ribs. The carapace is... They don't have like a bony carapace, and I'm not even sure if they would have had dermal ossicles like a Dermacaliod. I don't know if we really know. Because again, these guys, it's a rib cage. There's a cast of an Archelon skeleton, partially sculpted. So yeah. But leatherbacks are like this too. So yeah, I don't think... I do doubt that this actually is... I mean, it could be fossil turtle. I don't know enough about the texture of fossil turtle bone to tell you whether or not this is legit, but I kinda doubt it. Yeah. Anyway, landlord Sweetie Pie here is demanding payment. Huh. Yeah? You demanding payment before we do Metazua? Yeah? Oh. Whoa. Yeah, okay. Okay. We can make that happen. We can make that happen. Yeah. We can make that happen. Well, you're drooling on the desk. You're making a mess. You're making a mess. There you are. What do we got for you? Let's put these in here. Some more grainies in here, because I know you could use that. Dental treats. Let's try this. Let's try this. What do you think? They're good? Okay. So Twitchy Nose Rabbit says, what do you call the part that resembles the shell of an Archelon? So we would still call it the carapace and the plastron, but they'll be different. They don't have the... They don't have the same, like, ossified carapace and plastron that I'll explain in a minute. It's kind of hard to just... I want to be able to show you rather than just tell you. It's like, that was so good. Is there more anywhere? Is there more? Do you want some more? Look at that tail swish back and forth. Look at that tail go. Yeah. What do you think? You satisfied, or do you demand more? And Golganek says, can we infer from the flexible shell that Archelon would have been a deep diver like Dermichelys? That's a great question, Golganek. We're not really sure. Part of me wonders whether there were waters as deep as leatherbacks can go where Archelon lived. So here's the thing, is that Archelon is so far, I think, only known from North America, from the Western Interior Sea. So there we go. Let's do 90 million years ago. This is about what our Earth looked like about 90 million years ago. This is around the time that Archelon was doing its thing. Although they probably existed until the end of the Cretaceous. Fossils of it are a little scarce, but anyway, there was an inland sea in the middle of North America. See how this is dark blue and this is light blue here? That roughly correlates to depth. So this Western Interior Seaway here was not particularly deep. We're talking about maybe on the same order of like much of the Caribbean or the Mediterranean Sea today. Average depth of the Mediterranean Sea. 4,900 feet. Oh, shoot. The Mediterranean might actually be a lot deeper than the Western Interior Seaway. The tricky thing is, when we're talking about the Western Interior Sea, we're not talking about just one sea. Like, we're talking about millions of years here. So sea levels would have risen and fallen, the seaway would have advanced and retreated, so its average depth would be constantly changing over millions of years, you know? Unlike when we just say, oh, well, what's the depth of the Mediterranean Sea today? What's the average depth? You're looking at one moment in time, as opposed to millions of years for the Western Interior Seaway. But anyway, with the Western Interior Sea, I think Archelon has only really been discovered in South Dakota, if I remember correctly. That might be sampling bias. It could just be that it's not been recognized from elsewhere. It could have lived all over the world, but we don't really know. But I doubt that there was super, super, super deep water really anywhere in the Western Interior Seaway. It would have been mostly relatively shallow, like maybe only a few hundred meters at most, is my guess. So yeah. At its deepest, it may have only been 800 or 900 meters deep, shallow in terms of seas. So yeah, 2,600 to 3,000 feet. Leatherback turtles today will dive deeper than that. Just kind of no problem, they'll do that. So they'd be hitting the bottom. That still might be deep enough. That's still way too deep for like a hard-shell turtle to dive. So maybe Archelon was adapted for deep diving. And maybe it was adapted for super deep diving out in the open ocean, but we just don't have fossils of it from there. We only have it from the Western Interior Sea. Let's look that up again. Archelon doesn't appear in this article, so let's just search it here. Archelon. Bingo. South Dakota. More South Dakota. Pierre Shale. Yeah, I think it's only known from South Dakota. Yeah. Anyhow. But yeah, I don't think it's known from outside of the Western Interior Seaway, but here's the thing to remember. When we're talking about stuff like this, when you're talking about creatures from the late Cretaceous period, it's like we're looking through a tiny little keyhole. It's like we've got a very limited view of what life was like at that point in Earth history because we only have a few rocks, a few layers, like a few areas where rock is exposed on the surface that we can study. You know, we're trying to get a glimpse of what the world was like at that point in time, but our point of view is very narrow. Does that make sense? So maybe Archelon did have a cosmopolitan distribution, like the modern leatherback. Maybe it lived all over the world, but so far it's only been found in South Dakota, to my knowledge. But yeah. But yeah. Yeah. And welcome, Shepard3950. Good to have you here. Yeah. And MacMaster... No, that was a human cover of a song by The Doors. I don't have any AI-generated music, to my knowledge. Yeah. I think it was by the band The End. It was the, they did like a surf rock cover. And Diplotomodon says, Atlantocheles is from New Jersey / the Atlantic, so we know protostegids were there at least. Yeah, and we have them from Europe too, I think. And I want to say from Asia. Protostegidae. Archelon in particular, I think, is only known from South Dakota so far. But, yeah. Taxonomic history. Yeah, Santanacheles is from Brazil, I think. Yeah, Brazil. Solnhofia is from Germany, which may or may not be hang on. Solnhofia is that's a thalassocalidian turtle, never mind. But yeah, there's a bunch of different ones. Dysmetacheles, I think, is from Japan. And that's thought to be a protostegid. No, wait, no, never mind. This one's from the Western Interior Seaway. Nebraska. Yeah. Anyway, I'm pretty sure there's other protostegids known from around the world. They did a more or less cosmopolitan distribution, like they were all over the place. Ceratosaurus from the Czech Republic. Kansas Stega, obviously from Kansas. Notoculone is from, I think, from England. Let's say Petulant, there we go, is from, I hope I'm saying that right, is from Morocco. Yeah. So this group of turtles, the protostegids, the largest of which are ones like Archelon, they lived all over the world. So there's a reconstruction of Archelon right there. Really, really cool. And note, not a dinosaur, Landon History Buff. These were turtles that lived during the Mesozoic, during the Cretaceous period. So they lived at the same time as the Cretaceous dinosaurs, but they're not dinosaurs, they're turtles. So yeah. Thank you, Charlie's Dragon, for clearing that up. So yes. We actually encountered a few different Archelon specimens. Archelon casts, I should say. One of them was back in May. There we go.
People can do that.
Yeah, thank you. And Sharon is one of more than 400 volunteers.
Holy cow.
So this is at Loggerhead Marine Life Center in Juno Beach, Florida.
Excellent. Thank you, Sharon.
My pleasure. Have a great visit.
Thank you.
And then I'm sure you guys will.
Yes. Oh my goodness. Archelon issykairos, the largest turtle that has ever lived, as far as we know so far. We could always find a bigger one like tomorrow, but there are a few contenders, like fragmentary ones, like Gigantocheles from Egypt, I think, that could be bigger, but we don't have enough material to really tell yet. But look at this. I want to give everybody in the chat just a sense of scale here. It's got to be like 15 feet from zipper tip to zipper tip, right?
Oh, interesting. Would you know, Travis? Huh.
Common favorite of the kids when they come in here, and the first thing, of course, they ask is, "Oh my gosh, is that real?" Right?
This one is a cast, yeah. But,
it is a cast, but just to give them an idea that a prehistoric sea turtle that was that size lived is an amazing thing for them to see.
Absolutely.
That's pretty darn cool.
So for anybody in the chat who's not familiar with Archelon, these guys lived in the late Cretaceous. They're from the western interior seaway of North America. I think the holotype of Archelon is from South Dakota, if I remember correctly. So these guys are swimming around at the same time that... Yeah, there we go. Nice. Excellent. Thank you.
Yeah. Try to make sure we have them.
Yeah. This is brilliant. Justin was telling me that Jeanette Weineken kind of demanded some changes be made to the skeletal mount because they weren't quite accurate.
Oh, okay. I wasn't here for that, but I would believe it.
Yeah. So shout out to Jeanette over at Gumbo Limbo. We're going to go visit her on Monday or Tuesday, and I'm very excited about that.
Are you going to see then the tethered little...
They don't have any at the moment? Yeah.
Okay.
So I was wrong about that. Here's a link to this, by the way. They did actually have baby leatherbacks at the time. It was, a surprise. There we go. We did actually get to see baby leatherbacks.
I thought I have to change up my my look.
So there's Dr. Jeanette Weineken, who is one of the world experts on leatherback turtles.
And so the diving by the young guys is kind of a surprise.
Oh, here we go.
Before we move on, can I give you a thank you gift for the lab? And it's going to be a little bit sweaty because I've been hiding it behind my back. But
cool! Look at this!
That's so cute.
Oh man,
that's awesome.
We gotta put that right there.
Yeah, all right.
That's
I love
awesome.
it.
Thank you.
You're welcome. Yeah,
That's wonderful. That is way cool.
And Shepard says, how big are baby leatherback turtles? You're about to find out.
I figure out a way to put that up today.
Yeah, we'll figure it out.
Excellent, yeah.
Do you want to see some?
Oh my goodness. Yes, absolutely.
Some real life leatherbacks?
Yeah. About how much time do we have left, by the way? I want to be as respectful as I can. I know you're busy.
How about 25 minutes?
Okay.
Do you want gloves?
Gloves, yeah.
I'll grab some
Do
gloves.
we have gloves in here? Emily's gonna get gloves.
Okay.
We try to really respect these guys.
Right back. These are freshly
These are
hatched.
some of the turtles that came
Check this out.
from
Oh my goodness.
one of our early nests.
Holy cow.
All right.
Oh wow.
Are they my size?
They're mediums.
Oh, that's okay.
For you.
Thank you.
You're welcome.
Yeah, we try not to do too much handling
Right, yeah.
of them, just because we know from some of the genetic work that's happened that they don't have a really robust immune system.
Interesting.
Leatherbacks in general don't.
Mm-hmm.
Whether it doesn't matter, and babies typically don't. So this is a disinfectant.
Gotcha. I guess that makes sense for a critter that's not particularly social.
Yeah.
They're not interacting with each other that much.
Yeah. Yeah. So, anyway, these turtles came out surprisingly early.
Okay.
And so
wow. Oh my goodness.
A little, pretty little guy. Yeah.
Oh
and,
my goodness.
They're bigger than I thought they would be.
Sand on your nose. And so one of the things we do when they come in is check and see how normal they are. So we try to take as much sand off as possible.
Right, yeah.
And without...
So one of the things I was surprised by is that, well, I thought they'd be a bit smaller. Sweetie Pie, watch out. You're right in front of the camera. Anyway, yeah. I 3D printed a bunch of baby leatherbacks like this, and it turned out that they were way too small. They should actually be significantly bigger than this. So that was kind of a bust. I didn't realize, because I hadn't seen them in person up until that point, and I'd read that they were about this size, and apparently that was incorrect.
Totally abrading them.
Oh.
And then we calibrated this scale for today. So, what do you think? How much do you think?
How much do you think this little baby turtle will weigh, chat? Take a guess. What do you think? What do you think, Sweetie Pie? 50 tons? No, that's a little too heavy. A little too heavy. A little too heavy. So, grams or ounces. 0.7 kilos, says MacMaster. 350 grams, says Petrodactylus. 120 and 230, say Spartan and Jedi Mega Man. 120 grams, says Shepherd. 50 grams, says Kevin6x1. We're all over the map. Let's see.
I think that weighs.
Oh, goodness. I'm going to say 3 ounces?
Can we do it in grams?
Oh, grams? Oh, I don't know.
Okay, I don't know.
Let's just see.
Okay, I don't know if I can do... I think this only does grams.
Okay.
We can do the conversion for you. Come on, get your flipper off. 49.1 grams.
Okay.
Wow.
So who is closest in the chat? I think that would be Kevin6x1. Said 50 grams. There you go. Gamers Tavern Show, I think, comes in second there. Yeah. So, yeah, such a little baby. But they're, like, way bigger than other hatchling sea turtles. Some of the Ridley's sea turtles, I think, are the smallest when they hatch. So, a hatchling leatherback, significantly larger than other species.
Average is 45, so this turtle's a little heavier than normal.
Right, yeah. You're taking in a lot of that yolk, I presume.
Well, it hadn't totally used it up, so...
Interesting, yeah.
Yeah, that's the internalized yolk, and then they have a skin that's over it, so...
Oh.
Yeah.
My goodness.
Aren't you cute? Yeah. And lucky to be part of our team.
Right.
And then, okay, we got another one here. This one's used up less, so this one probably will not get checked in today, but it's not going to change its weight much.
So the big blob that you see on their ventral side in pictures and stuff,
yeah,
does that just get
it gets
sucked in like that?
Yeah, it gets internalized.
Wild.
How I don't know.
Off.
No.
Interesting.
Well,
which is cool. Like she says, how that works, I don't know. Jeanette Weineken is one of the world authorities on the biology of leatherback turtles. Their anatomy, their physiology, their behavior as hatchlings, as neonates. It's wild that there's so much that we still don't understand about these creatures, you know?
Yeah. The other egg membranes, the ones that look like they're kind of dragging something along.
Yeah.
That gets... Anyway, these guys are from our first nest, our second nest. The first nest actually got washed over, so we did not take turtles from that one.
My goodness.
So that's a little over 50 grams.
Mm-hmm. These are big.
These are big turtles. These are bigger than normal.
Right.
Bigger than our average.
I saw some at Loggerhead too.
Yeah.
Justin showed me some
cool.
before we went out for the nesting field work, and
yeah.
they're way bigger than I imagined.
Yeah.
I 3D printed a bunch of baby turtles.
Oh, you did?
And I did not print them large enough.
Yeah, well, the Loggerheads will be
way smaller, yeah.
Way smaller,
yeah.
so with the
But the ones
greens.
that I did were leatherbacks, and they were...
Yeah, so one of the things that's cool, this turtle has its eyes open. And, you know, they do have a upper lid and a lower lid, but it's sort of reoriented.
Right.
So it almost looks like they have a front and back lid.
Do they have a nictitating membrane?
Yes,
like
they
crocs?
do. Yeah, they do. They do.
Very cool.
All right, so that's okay, and then we haven't done you yet. So
Anyway, incredibly cool animals. I was so lucky to be able to see these.
So are they going to get names or numbers?
They get
And unfortunately, almost nobody got to see this live because I was broadcasting from Florida at the time, and this was, I think, about 9 or 10 o'clock in the morning, which meant it was about 6 or 7 a.m. here, California time. So that's way earlier than I normally stream. So we had most of our regulars were not here at the time. This is how it works.
numbers. We don't name our turtles.
Right,
I know
yeah.
that Juno Beach names their turtles, but yeah, we're being brutally honest scientists here.
Sure, yeah.
And we also
You're going to be re-releasing them,
yeah,
without tags or anything, so there's not really a need for names, I suppose.
Yeah, well, there is a need for numbers, so we can. Oh, look at this one's getting annoyed. See how pink it's getting?
Right, yeah, all flushed like that?
Yeah, that's all about
Interesting.
starting to raise its. You're doing things to me I don't like.
Oh.
So it's turning pink. That's leatherback for leave me alone.
Right.
Well, I still need to know how much you weigh.
Oh.
And they have surprisingly long tails when they're babies. So.
And that pygol process is surprisingly squishy, I guess.
Yeah,
I guess they were just curled up in eggs not too long
Yeah, they
ago,
were.
but-
They were.
Yeah.
So.
Oh.
51.9. So two.
It's so cool.
50.9. So we have a 50.6, a 50.
Oh, wow.
You are amazing. And yeah,
Just beautiful.
Yeah, beautiful little animals.
And their snout is such a funny shape too, so different from an adult.
Yeah, and then they have the carbuncle, the egg tooth.
Yeah.
There. And it's not like a bird egg tooth, so then it doesn't fall off.
It'll resorb?
They grow into it.
Interesting.
So if this is the egg tooth, it just kind of stretches out.
That makes perfect sense. Yeah.
And then they end up with that more blunt face. So guys, you got to wait a little.
So Akira Eclipses, where do they get them from? So these ones were from a nest that they were monitoring. It may I don't know if this nest was below the high tide line. So like when high tide came in, it would have been swamped or what? I don't think that's the case because they take a long time to incubate. But anyway, so what Jeanette and her lab do is that they monitor some of the nests. So when the mother turtles come ashore and lay their eggs, there are people that go out and flag each of these nests so that they can watch them. They can document how many of them actually hatch out, and it's all part of trying to record as much information as possible about these creatures because they are endangered. They are at risk of extinction. So the more we can learn about them, the more information we have, the better we can protect them. So Jeanette and her lab, they will sometimes visit a few of these nests, and if it's clear that a bunch of the turtles hatched out and then went out into the ocean, sometimes there's still a few stragglers. There's still a few that are left over who didn't make it out of the nest, and they would otherwise just die. As I understand it, her team will actually collect those babies, bring them into the laboratory, and then I'll show you the setup that they have. They didn't have this going when I was there, but when I was visiting, they had just collected these turtles, I think that morning, or maybe the morning before, and they were going to put them into this laboratory setting. Hang on a second. Where is that video? I know it's in the playlist, but here it is. Excellent.
These are leatherback sea turtles.
We know so little about leatherbacks, especially at the hatchling and juvenile sizes. So it's really incredible to get to work.
And yep, it is indeed tethered swimming.
Attention students, it's time once again to choose a gym class for the coming term, so let's all prove how adult we can be by filing to the gym in a calm and orderly manner. Even though it's first come, first serve, and the most popular sports fill up fast.
Too many wee ones!
This gets uglier every year. Any sign of Barton Millhouse? No, and if they don't get here soon, it'll be TS for them.
I don't feel right.
Tethered swimming. It is right for leatherback turtles because as a pelagic species, as like an open ocean species, they don't really register like barriers, boundaries, solid objects. They're used to being out in the open ocean where it's just open space around them. So if you put them in captivity like this, they will just run into the side of the tank repeatedly until they disintegrate. So you have to tether them like this.
Work with them at those life stages that you would not see out in the wild. We've seen the populations of other sea turtles increase over time, especially due to different kinds of protections. But the leatherbacks especially are very mysterious and unknown. And you need to know about a species before you can help it.
Yep. Anyway, really cool stuff. So I got to visit there back in May. Here is a link to that VOD right here, if you want to watch the rest of that.
I'm here to applaud the work of vertebrate paleontologists.
Dazed Smurf, thank you for the follow. Welcome to Paleontologizing. Good to have you here. So anyway, I got to see adult nesting leatherbacks on the beach in Juneau, Florida. I got to see the hatchlings in the laboratory. They only had their first 3 of the season here, Petrodactylus, so there were none actually in the tanks yet. These were the very first ones of this season. And I got so lucky in being able to see them. We were not expecting this. It was kind of a fluke. So we got really lucky. But yeah, hopefully in just about 2 weeks. Yeah, in 2 weeks I'm going to be out in the field off the coast of San Francisco, tracking down these turtles and helping with fieldwork there. On this vessel.
Welcome to this week's episode of Looking for Leatherbacks.
Anywho, yeah, this is the vessel that I'm going to be on.
Over the past...
Called
Thanks
the Sheila
for
B.
amazing Captain JD and some handy adaptations made to the Sheila B research vessel.
Hi guys, my name is John Douglas, better known as Captain JD. I'm with Moss Landing Marine Laboratories. Let's have a little look around the Sheila B. We'll start up here on the foredeck. This is where the turtles come aboard. One of the unique aspects of the Sheila B.
Serial Killing says, did we go to the moon on April Fool's Day? Did you? I don't know. Are you an astronaut? Welcome to Paleontologizing. I'm a paleontologist. We're talking about extinct organisms and living ones too, like leatherbacks, which also date back to the Cretaceous. That's why I'm so interested in them. And then we also have occasional visits from other species too, like Ms. Sweetie Pie here. Yeah. But yeah. Anyway. Welcome to Paleontologizing. I'm slated to be on this vessel in just a couple weeks.
That is critical for landing turtles is our bow door, our ability to lower the door and open water. And this is what it looks like. That goes down.
Anyway, very cool. More about that as it approaches, but again, I'm getting ahead of myself. I'm getting too excited about this. Going on too many tangents, huh? What do you... She wants more treats. Landlord here is... Oh. You're insatiable. You are. You are. Yeah. Okay. Okay. Oh, there we go. It's a piece for you. I'm gonna get some Sweetie Pie emotes going in the chat. For my very demanding landlord here. That's a little too many. There we go. Yeah. Good stuff, Sweetie Pie? What do you think? Oh, yeah. Anyway, we'll do some Metazua in just a minute here. We've got 2 rounds of Metazua today, because I will not be live tomorrow. So we might as well do tomorrow is when it refreshes. But yeah. Anyhow. Wow, did you eat all of those, Sweetie Pie? Good job. Gonna get all the crumbs too? Well done. And she really liked those. Get all the crumbs? Good job. Good job. She's like, don't touch me, I'm eating. I'm sorry, Sweetie Pie. Oh. You gonna push the camera around? She loves doing that. Oh! Now she's fleeing. Anywho, as we were talking about earlier, all creatures on our planet, from the domestic cat, like Sweetie Pie, right here, there we go. All creatures on our planet, from the domestic cat to the leatherback turtle, they're all related to one another. They share a common ancestry. There's the leatherback right there. All the way to leatherback to lavender. There we go. Type of plant. Every living thing on our planet is related. And when I say related, I don't just mean, oh, they look similar, or they've got similar vibes, or whatever. What I mean is they're literally related through familial relationships, evolutionary relationships. They share a common ancestry. And man, it takes a long way to get to a flowering plant like lavender. This is an incredibly speciose group. The flowering plants are, holy moly, are they diverse. So many different species. There we go. Shoot. Because all life on Earth is related and shares a common ancestor, we can actually make sense of these relationships. We can actually figure out when different groups diverged from one another. We do this through the use of genetic testing, looking at DNA. The similarities and differences in genetic codes tell us how long ago different critters diverged. We also look at this through the fossil record. So we can kind of use different methods to test them against one another and get a better idea, a more holistic approach for like figuring out the interrelationships of living things on our planet. And because that works, we can do our daily animal guessing challenge called Metazoa. And we can try and figure out the mystery species of the day in as few guesses as possible. This provides a lovely excuse to talk about phylogeny, the tree of life. Phylogenetic tree, evolutionary tree, whatever you want to call it.
That gives the history of life its very quirky, fortuitous, chancy character. We are literally here only because of the good fortune of dinosaur extinction.
In chat,
Thank you, Chagrin Falls, for the 7 months of support. I appreciate that deeply. Thank you. Yeah. And Kikoshi Za says, 2 of my friends think humans are aliens or mated with aliens? Where did they get that idea? I don't know. I used to work with a guy who had the same idea, but with elves. He claims to be deeply convinced that elves were a real thing and that that's where humans came from, and humans are not related to any other creature on our planet, but that human beings were descended from elves. And I wasn't quite sure if he meant in like the Santa Claus sense or in like the Lord of the Rings sense, and he like kind of refused to elaborate on that. Yeah. Anyway, this is the thing about science, is in science, when you say something like this, you have to be able to back it up with evidence. You gotta put your money where your mouth is. And that's what we've been able to do here in figuring out the history of life on Earth, you know? And holy cow! Kitboga! Holy moly! Thank you for the raid. I appreciate it.
Kitboga and their 1792 raid.
Welcome, Kitboga and Raiders. Holy cow, I'm gonna have to turn our alerts off real quick. Thank you, Kitboga. And Raiders, thank you, new followers. The Only Human, General Desaix, DX Pong, Twin Blast. Thank you to everybody who is following, just followed, or is about to follow. I really appreciate that. Welcome to Paleontologizing. My name is Danny Anduza. I'm a dinosaur paleontologist, and I gotta turn alerts off on this scene as well. Welcome, everybody. We're gonna be assembling a life-size Diabloceratops skull in just a little bit. So if you'd like to stick around for that, that's gonna be pretty rad. There we go. It's gonna look like this, but it's quite large. This is a dinosaur that's near and dear to my heart. Friend of the channel, Don DeBlue, discovered this critter, and it's now pretty famous. Diabloceratops. Here's what I have from it so far. It barely fits on this ceiling. Shoot. It's gonna be a challenge to keep this in frame. But we'll be putting the face, the nose, the jaw, upper jaw on it today, and the beak. And all that. We're gonna do some Metazoa, all kinds of good stuff. But anyway, Kitboga, I hope you had a superb stream. I'm sure you did. You always do. Thank you for bringing everybody over. Let me play a quick little channel trailer video for you to introduce you to what we're all about here on Paleontologizing. Here we go.
My name is Danny Anduza. I'm a dinosaur paleontologist, and this is Paleontologizing. Science isn't just test tubes and beakers and white lab coats. what we're doing out here is science too. We're testing hypotheses by excavating these fossils.
Join me for museum tours, interviews with other paleontologists, audience Q&A, 3D printing.
It's pretty big. Who thought this was a good idea? That was a life-size T-Rex skull that I 3D printed, and it's now at the Children's Natural History Museum of Fremont in Fremont, California. It's been a big hit there. Very proud of that.
And of course, live dinosaur digs.
A limb bone from a new duck-billed dinosaur.
I invite you to tune in and experience the adventure of fossil science.
Welcome, welcome. Here, let's pull up that video real quick. They're still working on their renovations there.
But it's disappeared. I was working on this as recently as this morning, just trying to get it ready for delivery. But take a look at that. Yeah. So this is the Maximus Tyrannosaurus skull. So this is a commercial specimen. This, to my knowledge, is the first time that this particular specimen has ever appeared in a museum. So the original was dug up on private land by a commercial group, and then it was sold at auction. They were expecting to get like $20 million just for the skull.
Ridiculous.
And they ended up
Don't
getting
get me started on these auctions.
Which is still vastly overpaid for it, whoever bought it. But it's disappeared. It's in a private collection somewhere. Nobody seems to know its whereabouts, but briefly, some files appeared online on a 3D printing website, a scan of the skull, and I was able to scoop those up before they disappeared just a couple days after that. And so with those files, I was able to 3D print this life-size, and now here it is to be enjoyed by all the visitors to the museum. Right now it's right here in kind of the lobby area. We're going to go upstairs in a moment and take a look at some of the fossil exhibits, but I wanted to show this to you first. We'll return to this, and I can talk about various aspects of the skull.
I don't know if we did return to it during that stream, actually. I think we were too busy doing other stuff. Here's a link to that VOD if you want to take a look at that. But, anyway. Thank you, Kit Boga, for the raid. Really appreciate it. And Rustic Lizard, what a great name. Welcome to Paleontologizing. Yeah. We do a lot of 3D printing on this channel.
Wow.
And,
need to salute the paleontologists.
We try and do 3D printing only for good. To make replicas of fossils, to use as teaching aids, for distributing to different museums, all kinds of stuff like that. So, yeah. We were just about to start talking about phylogeny before we jump into our daily game of Metazoa, our daily animal guessing challenge. But before we do that, since we've got so many people watching, I think it's probably wise to switch our category from science and technology to just chatting. Because, we are surely at the very top of the science and technology category right now. Yeah, there we are. Let's not be a big fish in a small pond. Let's be a smallish fish in an ocean. We can bring some more people in to talk about science today with us if we switch categories. But yeah. And Shepherd says, what's that big bone on the wall from? This is a femur, 3D printed, of a big sauropod dinosaur. Sauropods are the long-necked, plant-eating dinosaurs like this. I think this one is from Apatosaurus. It might be Diplodocus. This is printed, I mean, you could print it at different sizes for different sized individuals. This would be like a smallish individual. An animal probably about 30 or 40 feet long. Apatosaurus itself, usually around 80 feet long, something like that. Some of them could be close to 100 feet long. It all kind of depends. The very biggest of the sauropod dinosaurs were truly enormous. Yesterday we were talking a little bit about diplodocid sauropods. Here's Matt Wadle here, who's a sauropod researcher, with a giant femur of an apatosaurus from Oklahoma. And I think he's giving it a little kiss right now. Matt Wadle is one of the world authorities on sauropod dinosaurs. Cool guy. We really need to bring him on for an interview at some point. But Anime Body Pillow says Dusa. Yeah. He frequently refers to sauropods as God's most perfect creatures, which I think is really cute. But Diplotomonun says classic Matt. I know, right? Yeah. Anyway, this is a sauropod. I think Apatosaurus in particular, the femur there. This would be a small femur. They get really, really, really big. Which actually brings us to something that I forgot to share earlier. On yesterday's stream, we talked a bit about Dolly Parton, recently passed, and her scientific legacy. There's a bunch of different scientists who have honored Dolly Parton by naming various critters after her over the years. And a brand new one, it's not been published yet, but this is a, well, it's not been published as a new species yet, but this is a sauropod dinosaur. This specimen has been published on, but hasn't been named yet. Some of the cervical vertebrae, the neck bones, show evidence of a respiratory disease. We talked all about this yesterday. The specimen itself is nicknamed Dolly, after Dolly Parton. So this is published in 2022. Kerry Woodruff is lead author, and Matt Wadle here is one of the co-authors. But I texted Kerry at the end of yesterday's stream, and I asked him if I could talk about this, because I'd heard a rumor that he was going to be naming this animal after Dolly Parton. He says that won't be the official genus and species name. That'll be named after maybe some landowners who let him dig up this specimen. But anyway, he says, did you know that we nicknamed a special dinosaur in honor of Dolly Parton? Dolly is the first non-avian dinosaur with a respiratory infection. And Dolly is also a new genus. A genus is a closely related group of species. So Tyrannosaurus rex, Tyrannosaurus is the genus, Rex is the species. Homo sapiens, Homo is the genus, Sapiens is the species. So here's a teaser image. I often use pieces of art as human scale bars, but I could think of nothing more fitting than Dolly with Dolly. So here's Dolly Parton's silhouette here to show the scale of this animal. So this is not a particularly big sauropod. This would have been a subadult. But this specimen has been nicknamed Dolly because Kerry Woodruff is a huge Dolly Parton fan. And there's Dolly herself right there. This is going to be the official image in this scientific paper. So I think Kerry is going to be publishing in this, hopefully this year. And I'd bet my boots that Dolly Parton is going to be mentioned in the official acknowledgments in the scientific paper once it's published. So yeah. But yeah. Anyway, approximately 3 dollies tall. Exactly, Golganek. Yeah. Anyway, you should go follow Kerry on Blue Sky if you happen to be on there. He doesn't post that often, but he's got really cool things coming up. So stay tuned. Anyway, now we lost Tim Curry. I know, right? The only human? I was just thinking about that this morning. You know, brief digression about Tim Curry. I think everybody's got a favorite piece of Tim Curry media. You can put yours in the chat if you'd like to. I would say mine would have to be either his role in The Hunt for Red October, but most likely his role in Muppet Treasure Island. It's unironically an excellent film, and he elevated that movie so much with his performance. He just made it super fun. Yeah. In college, that was like my girlfriend's favorite movie. Kind of ironically, but mostly unironically. She's really liked that film. And she introduced me to it, and it's a really good movie, you know? Anyhow. They named him an honorary Muppet? Really? Cambridge Tavern Show. That's a big honor. Yeah. Anyhow. So, big paleo salute to Dolly Parton and to Tim Curry. I'm honored to have been able to share this planet with them for as many years as I've been alive. And that's a privilege, you know? They made the world a better place. Yeah. And Command and Conquer, I'm familiar with this Petrodactylus, yeah. Space! Yeah. Fabulous Old Muppet Memory says, "Voodoo poo poo." I'm glad. Glad to bring back a happy memory. Let's talk about phylogeny a little bit before we dive into Metazoa. There we go. Thank you for the follow. I appreciate that very much. This is one of these things that I try and bring it up sometimes when we get a really big raid, because it's like the fundamental principle in all of biology, and rarely does it get taught in school until maybe you get to like the undergraduate level. And there's an excellent video about this. I think so, at least. Where was that? Bear with me here for a second. Here we go. It was stated clearly, I think. I think it was this one. We'll at least take a look at the beginning of it, and then we'll use it as a springboard as we jump into Metazoa and talk about how living things are related to one another. Here we go. Yeah.
Stated Clearly presents, what is the evidence for evolution?
Yeah. So again, this is like the fundamental principle in all of biology. When people think of evolution, they often think of old Chucky D, but the thing that I like to say is that if Charles Darwin had ever been born, or say the HMS Beagle had sunk as soon as it left Plymouth Harbor or wherever it left, we still would know about evolution today. Somebody else would have discovered it. That's the cool thing about science, is that to a certain extent, it doesn't really matter who discovers something. What matters is the idea itself. It's not like somebody has to come up with an idea in order for it to be a thing. We're trying to study the natural world. We're trying to figure out how things really work. We use evidence, we test ideas, and if... It's kind of lousy that, like, every time you see Darwin, he's always this old, bald guy. He came up with his best ideas when he was a young man. That's when he did his voyage of the Beagle. I guess he's still on his way to being bald right here. Shout out to all the bald kings out there. Anyway, even if he had never come up with this idea, somebody else would have. In fact, somebody else simultaneously was coming up with the idea for natural selection at the same time as Darwin. His name was Alfred Russel Wallace. And he and Darwin kind of independently had this same notion. They might mention that in the video or they might not, but anyway.
Biological evolution makes two very bold claims about living creatures. First, all living things on Earth are related.
Yep, and this is why we're watching this video.
They evolved from a common ancestor. Second, the evolution of living things is powered by natural processes, things which can be studied and understood. But is there really any evidence that these two claims are true? Yes. There are so many observable facts from so many different fields of study that the only way we can even begin to talk about them is to group them into categories or lines of evidence.
Yep. And the Only Human says, phylogeny rules. The fact that we're more closely related to goldfish than sharks, that's awesome. Yeah, absolutely. Not just that, the Only Human, but another cool thing. I'll get back to this in a second. Here. There we go. All right, I'm going to show you an image here in just a second, so get ready. It has 3 different animals on it. I want you to tell me which 2 animals, A, B, and C, which 2 of those are the most closely related. You ready? Let's go. There's a salmon, A, a lungfish, B, and a cow, C. Which 2 of these are each other's closest relatives? Pumpkin the cat says the lion gives it away. Don't people don't realize that necessarily. But yeah. Yeah. The correct answer is the lions do give it away. B and C are more closely related to each other than either one is to A. A cow is more closely related to a lungfish than either one of them are to the salmon. Pretty cool, right? And I can show you that on a tree of life here. So, go to the vertebrate animals here. Here we go. So here's animals with bones, the bony vertebrates. This includes reptiles, amphibians, mammals, bony fishes. Strictly speaking, they're all bony fishes, like technically. But here we go. Here are the lungfish and the tetrapods, called Dipnotetrapodomorpha, but you don't have to worry about that name. It's kind of a mouthful. Lungfish are right here. They are more closely related to the tetrapods, including mammals, including cows, than they are to the salmon. And I'll show you. We can use this handy tool. Salmon. Here we go. Oncorhynchus. And lungfish. So salmon and lungfish last shared a common ancestor about 430 million years ago. It's way back in the Silurian period. Long, long, long time ago. So 430, remember that number. Now, let's do cow and lungfish. Cow, Bos taurus, they shared a common ancestor only 415 million years ago. That's a difference of 15 million years. Lungfish are more closely related to cows than they are to salmon. Pretty cool, right? Yeah. And Imiku says, we're lungfish. We just brought the water with us onto land. In a certain sense, yeah. Yeah, you're right, Imiku. Correct me, please, if I mispronounce your name. I don't want to butcher that. But yeah, the ancestor of all the mammals and reptiles and amphibians was a critter not unlike this. Little Tiktaalik here. We have fossils of this and other fishes that were in the process of coming up onto the land. We've got a pretty decent record of this nowadays. Call those critters fishopods because they're kind of halfway between like a fully aquatic fish and a tetrapod, a four-footed land animal. So this is just a handful of the different species we have. These are reconstructions. We've got fossils that show what these critters looked like. Give us a pretty good idea of what the range of motion was on their limbs and, you know, how adept they were at moving around on land, that kind of thing. So nowadays we've got a bunch of in-betweens interspersed throughout all these too. So it's a more smooth gradient than this would even suggest. It's pretty darn cool. And it has inspired people online to post stuff like this. If you had a time machine, what would you go back and fix? Me? Go back into the water. You're telling me that, you know, 425 million years ago, a fish clambered up onto the land and now I have to go to work and pay taxes? Nuts to that, you know? Anyhow. The ultimate grandfather paradox. There you go. Yeah. Yeah. So anyway, let's get back to that video here. What evidence do we have that living things change over time and that they're actually related to one another? Oh, this is just a start here.
To keep things simple, here we'll focus on evolution's first claim that all living things on Earth
Spark electronics,
are
yeah.
related.
Yeah.
We cannot tackle the entire tree of life at once. After all, there's an estimated 8.7 million species alive today.
That's a
so
lot.
Instead, we'll focus most of our attention on one fairly small but fascinating branch of the evolutionary tree, cetaceans.
The whales. The baby whale, Jay.
This branch includes whales, dolphins, and porpoises.
Yep. Which, I mean, talk to any paleontologist and they'll refer to dolphins and porpoises and those guys as being a kind of whale. When we say the word whale as scientists, usually we mean cetaceans. So this is that whole clade. Hello, Mini Pie. And we're getting another visit from one of my landlords here. Here, we gotta pay the landlord. Hang on. Then we'll get back to these other mammals. Although the ancestors of these guys did look a lot more like cats than they looked like whales. We'll get to that. But yeah, hello Mini Pie, how are you doing? Alright. There's a live broadcast. We get interruptions like this. It happens, huh, Mini Pie? And thank you, Seabot-Berry55. Or Volcure. Oh, we gotta mute the
age of reptiles.
Sorry. There's gonna be so many. We have so many follows. Thank you, everybody. Mini Pie, how are you doing? How are you doing? Yeah. Look who's dressed up. Yeah, she's got a new bow. Lordy made a bow for Mini Pie here. Huh. Look, very dapper. I'm underdressed now, you know? But I'm not a member of the property-owning class like you are, huh? No. Of course you're wearing a bow tie. Yeah. Alright, is it time for me to pay rent? Okay. Okay. Compliments of the chef. Good stuff. Is he making a mess? That's okay, it's a vacuum cleaner. Don't worry about it. It's not gonna get you. She hears the vacuum cleaner in the background. Yeah. So many treats. You get them. She likes the personalized attention. She likes the treats being brought to her. Look at all these crumbs. Look at those. You gonna get those? There you go. Clean them up. You're just spitting out crumbs. You're so messy. Oh, yeah. There we go. All right, let's get back to our cetaceans here.
Biologists tell us that all these creatures are closely related, and that the entire group evolved from an ancient four-legged land mammal.
And what's the whole white coats thing? I've not worn a white lab coat in years and years. And the last time I did, it was not doing science. It was like doing some screen printing, making t-shirts. Anyway, this is what society thinks scientists look like. Oh, they all wear white coats, right? Oh. Paleontologists usually don't. Anyway.
Instead of taking their word for it.
And hang on a second. Billy517, thank you for the raid. Welcome to Paleontologizing. It's good to have you here. Thanks for joining us.
Let's look at the facts. We'll start by looking at a few from the field of comparative anatomy, the study of differences and similarities between living things.
Gamers Tavern Show. I don't know about that. That'd
Whales live in water, and from a distance, they sort of look like giant fish. A close inspection of their anatomy, however, tells us a very different story.
Thank you, Billy,
Whales,
for the raid.
just
welcome,
like
welcome.
land mammals,
Good to have
but
you here.
unlike fish, have placentas and give live birth. They feed milk to their young.
Yep.
They are...
And whale milk is actually really weird and thick. I've heard it's kind of the same consistency as like cream cheese, because it's got to be extremely fatty and nutritious because their young have to grow very fast. It's wild stuff. Whale milk. I don't know if that's a real picture. And I don't know if that's actually whale milk there. Yeah. Anyway, it's extremely thick stuff. Highly viscous. Super, super fatty. Yeah.
Birth. They feed milk to their young.
Yep.
They are warm-blooded, which is extremely rare for a fish. And whales do not have gills. Instead, just like us, they breathe air with 2 fully developed lungs. Whales don't seem to have noses like mammals do. Instead, they breathe through blowholes coming out the tops of their heads.
But that is a
Some
nose.
whales have 2 blowholes which almost look like nostrils.
They are.
But dolphins and porpoises only have 1.
Also a nostril, though.
Surprisingly, if you look at their skulls, you find that the blowhole splits into 2 nasal passages inside the head. Could it be that the blowhole is actually a highly modified mammal nose? It looks that way, but we'll need more evidence to be sure. Many whales have hair, just like land mammals. In this photograph, you can actually see the whiskers of this baby gray whale as he rests his chin on mama's back.
Pretty cool.
Strangely, whales have arm, wrist, hand, and finger bones inside their front flippers.
Yep.
Here's a photo of
Just
these
like we do.
bones. The same bones that bats, hippos, and people have in their front appendages.
Along with cats and rats and wombats, all mammals have got those same bones in their forelimbs like that.
1 bone, 2 bones, wrist, hand, and finger bones.
Yep.
Modern whales do not have back legs, but they do have a strange pair of bones where the hind legs should be.
Yep, and the next time you're at like a museum or an aquarium or something and they have a whale skeleton on display, or you can just look it up on your phone or on your computer. Pay close attention to what's going on where the hips should be, because as a wise woman once said, the hips don't lie. You've got remnants of the hip bones there in a whale skeleton. That's labeled C right here. Hip, and there's also remnants of the hind limbs on this. I think this is a bowhead whale. How cool is that? Remnants of the hind limbs. This points to a terrestrial ancestor of whales. The ancestor of whales had legs. It lived on land. We know this through genomics by studying their DNA. We know this through the fossil record. I'm sure he'll go into detail about that here in this video, or at least mention it.
Here's a picture of these bones from a bowhead whale. They almost look like shriveled hip, thigh, and shin bones.
Because they are. But yeah, and Hanny says, do they use those bones for anything today? No. They don't have legs anymore. This is just inside the body. These are remnants. It's vestigial. And yet they still have it. It points toward their ancestry, you know, back when this sort of thing was useful. Really neat. Special Agent Bob says, in all seriousness, though, whale skeletons are seriously cool the more you look at them. They're rad. They're so neat.
This one even has a ball and socket joint between the hip and thigh bone, just like the ball and socket joint in your own hip. Is this resemblance a mere coincidence, or are these real leg bones? Perhaps leftovers from the whale's evolutionary history.
How would you test that sort of thing, I wonder? Given that science is about not just saying stuff, but science is about testing ideas, what are some ways in which you could test whether these really are the remnants of limb bones? What are some ways that you could test if whales maybe had terrestrial ancestors who lived on land? Type some guesses into the chat. I mean, what are some different ways that you could try and prove or disprove that idea? Very funny too. Yeah, definitely. The Bible's definitely a textbook about biology. That's definitely why it was written. Yeah. Look for in-betweeners, says And It Then Did. Yeah. Ask them, says Gene Wen. I don't know if they're talking. They could be surprisingly cagey animals. Yeah. Catch one of them whales that has back legs, sandwiches. You joke about that, but there are actually examples of whales with atavistic traits. Like once in a while, every once in a while, there will be a whale born that's got vestigial legs, like as an atavistic trait. So here we go. That is a dolphin that has hind flippers. It's a mutation where they have that vestigial limb like left over. Really wild. This is more common in like stillborn whales, because often if they've got a mutation like that, or they have that ancestral trait that shows up again, often they have other things wrong with them too that mean that they're not... Something happened and they're not necessarily, like... They end up being stillborn, is what I'm trying to say. Yeah. This is from American Museum Novitatis, which is the in-house publication for the American Museum of Natural History in New York. A remarkable case of external hind limbs in a humpback whale. This is a whale that was literally born with that ancestral trait. In the same way that sometimes humans are born with a tail. It's rare, but it happens. Exactly, Tostovis, yeah. Yeah. Occasionally you'll get a whale like that. So yeah. Supertrain says just wait a billion years and they'll go away. I mean, billion what? Years is probably too long. Give whales another 100 million years. And they'll probably lose all remnants of their hind limbs. Anyway.
Before we draw any bold conclusions, let's see if a completely separate line of evidence will confirm our suspicions. Embryology is the study of how creatures develop before being born or hatching from an egg.
Oh, so anyway, this is... We had some of these lines of evidence People typed these into the chat, paraphrased, but people had these same ideas. Look at their close relatives, look at their DNA, look at how they're distributed, different habitats that they live in, look at the fossils, all that.
Here we see a dolphin and a human embryo side by side at similar stages of development.
Yep.
Notice that they both have what look like arm buds and leg buds. In humans, the leg buds grow to become legs. In whales, they grow for a while but then stop, effectively fading away as the rest of the whale continues to grow.
Really cool stuff. We'll return to this in a minute, but somebody mentioned one of my favorite modern mammal species, and so I have to do a little tangent here. It's a live broadcast. These things happen. But Satan Sandwiches there says, have you seen strap-toothed whales? Very unusual tusks. They are... Sometimes when people ask me, Danny, what's your favorite hoofed mammal, your favorite ungulate? I usually say the strap-toothed whale. This really weird kind of beaked whale where the males have these tusks that come up out of their lower jaw, and the tusks go upward, and then they go over the lower jaw, and they cross over the upper jaw, so they can only open their mouth like a sliver. It's really weird and cool. The strap-toothed whale, which is Mesoplodon... what's the species name? Let's look it up. Strap-toothed whale. Mesoplodon layerdi. There we go. Also known as the layered-beaked whale. They're not the biggest whale in the world, certainly not. But they live in the Southern Ocean around Antarctica. And there's a skull of a male strap-toothed whale. Those tusks come up from the lower jaw, and they go and they kind of meet over the upper jaw, and sometimes, in really mature individuals, they'll cross over like that. So they can only open their mouth a tiny little bit, which is really weird and cool. Strap-toothed whale. There is an illustration of a really mature individual. Really weird and cool. The beaked whales, this whole family, they're my favorite whales in general. They tend to live way out in the middle of the ocean. They're extremely deep diving. And some of them are so mysterious that they have literally never been seen alive by a person. At least, there's no documented cases of a person actually seeing one alive. They're known only from, like, carcasses that wash up on the shore. Strap-toothed whales have been observed in the wild and photographed, filmed, everything else. But other species in this family, the only reason we know they exist is because occasionally one will wash up on a beach somewhere and we can study a carcass. So they're not extinct, they're just rare and mysterious. Yeah. Anywho, really neat. The Mesoplodons in general are just really awesome. The strap-toothed whale is one of the weirdest and coolest. But there we go. There's a skull right there where you see those strap teeth, those tusks. And only the males have it. The females don't have the tusks. And the reason why they can do that, and they can survive with only being able to open their mouth a tiny bit, is that they are suction feeders. They only have to open up their mouth a tiny bit in order to create suction and then slurp up squid, which are their primary food source. They're so cool. They're really weird. Yeah. But yeah. And I guess less so for aquatic animals, but still incredible. I mean, they're often very shy, and they just live way out in the middle of ocean basins, far from land. So there are definitely species that are still undiscovered. And I can say that with confidence because about once a decade or so, there will be a new species of beaked whale that gets discovered and published on. The most recent of this is... It was just a few years ago. Is it Ramari's beaked whale, I think? Yeah. There we go. Ramari's beaked whale was named in 2021. Holy cow.
Bird.
Oh, wrong button.
Wow.
There we go.
Wow.
5 years ago. Brand new species of mammal. Just scientifically described. And they're not huge, but they're not tiny either. Yeah, pretty neat. It's not brand new, like, they were known to have existed, but they were so poorly known that they were previously thought to represent an Indian Ocean population of the True's beaked whale. Turns out when someone actually looked up close at a specimen, they're like, holy cow, this is a different kind of whale. It's a different species. We didn't realize it before. So, really neat. But every once in a while there is one that pops up where it's like, what is this? Just, what? What? So yeah. Really neat. Really neat. Anywho, whales. They're pretty rad. I know I'm a dinosaur guy. I know dinosaurs are what I study and what I publish on in the scientific literature. Dinosaurs are what I get most excited about. That's what I specialize in. But you gotta hand it to whales. They are really interesting animals.
These are all photographs of a common dolphin at different stages of growth. Notice that early on, we see 2 nostril grooves on the front of the face, just like you'd expect in a puppy or a human. As the dolphin continues to grow, the nostrils migrate to the top of the head and fuse together, becoming the dolphin's blowhole.
Mm-hmm.
So far, we have multiple facts from 2 independent lines of study, comparative anatomy and embryology, that are both telling us the same story. The ancestors of whales were once 4-legged land creatures.
Yep. Yeah. Son of Austerlitz says, aren't orcas also dolphins? They are. They're part of the Delphinidae, the dolphin family. And dolphins, in turn, are a kind of cetacean, a kind of whale. Darth Jace, thank you for the 2,000 bits, by the way. Really appreciate that, Darth Jace. 1,000 and then 2,000. Thank you, Darth Jace, for supporting science outreach here on Twitch. I appreciate that. Thank you. Yeah.
Will the fossil record act as a third witness, confirming this idea? These are 2 species of extinct basilosaurid whales.
Yep.
These animals are known for multiple well-preserved skeletons, and they appear to have lived side by side, roughly 34 to 40 million years ago. In this photograph, we're looking down at the top of a basilosaurid skull. This is not a model or a cast. These are the actual bones which were pulled from the ground.
Yep.
Notice that
Not pulled from the ground, metaphorically speaking. Carefully excavated, I presume. As a paleontologist, I try not to pull bones from the ground. I'm doing a little bit of a, well, actually thing right now, so forgive me, but I want to emphasize how slow and careful the process of fossil excavation is when done properly. So, yeah.
the nasal opening is not on the top of the head like those of modern whales, and not at the end of the snout like those of land mammals. Instead, it's right in the middle. This is an intermediate species, exactly what evolution tells us we should find.
Yep.
At the back end of a basilosaurid's body, there are small, yet fully developed hips, legs, ankle, feet, and toe bones.
Now this one's missing some of the toe bones because often when we find fossils, they're incomplete, but yeah. So again, hips, there's the acetabulum right there, the hip socket. This is the femur, the thigh bone. That right there, who can tell me what this is? Right here, this free-floating bone right there. What is that? I once dislocated this in 7th grade. That was extremely painful. And yes, indeed, if you said kneecap or patella, you are correct. Well done. That's the kneecap right there. That's a whale kneecap. Wild. Not inner ear bone airspace. Yeah. And Special Agent Bob says, would the hind limbs on Basilosaurus provide much help with mobility in the water? No, in fact, they probably would have been actively detrimental, harmful. It's not like they... evolved these legs, they're evolving away from having these. And I betcha that within Basilosaurus, which is this ancient whale species, ancient whale genus, it's called Basilosaurus despite not being a dinosaur. It's an ancient whale. But when it was first discovered, somebody's like, "Oh, dude, look at this giant reptile. We'll call it Basilosaurus, the king lizard." It's not a lizard. It's not a reptile. It's a whale. I'm guessing that within populations of Basilosaurus, when they are around, when they're swimming around, there's a bunch of different individuals. There's always like variability within a population. Every individual is a little bit different. I bet you there would have been ones with bigger legs and ones with much smaller legs, because they were kind of actively evolving away from having legs. That's just kind of where they were at. Kind of like with variation in human populations today. Different people look different. And even like different members of the same family are different from one another. You are probably different from your siblings or your cousins in various ways. I, for instance, am a carrier of an interesting mutation, I think. I bet you I can show you. This would have been back in January of this year. I went to the dentist. I went back last week, but I did not get to see the x-rays here. But I am missing my wisdom teeth. I only have one small portion of one wisdom tooth because well, maybe I got to go back to last August. Is that or July? Maybe that's when I went to the dentist. But yeah, I don't have the full complement of wisdom teeth. A good number of people have this. There we go. Excellent. So here is a photo. I've got one wisdom tooth right there, and it doesn't seem to be big enough that it'll ever have to be removed. I'm in my 30s at this point. I don't think this is ever going to need to get removed because that's an atavistic trait. Just like whales losing their legs over time through tens of millions of years of evolution, human beings are also losing their wisdom teeth. Some people have big ones that need to be removed. Our ancestors had them fully developed and everything. But we don't need them anymore. We're kind of evolving away from that. And I only have one right here. I've never had to have any of them removed. I was just born without them. And now there's one kind of smallish one right there that doesn't seem to affect me enough to really need to be removed. So yeah. Realerolus is me neither. I have none. There you go. Yeah. So anyway. Hello, sweetie pie. You're back. The third time? Goodness. And you had 6. Interesting, Super Train. You know, again, this is one of these sources of variability. And I betcha that with Basilosaurus, some of them would have had longer legs, some of them had shorter legs, because it's like a thing that they were actively... You know, there's like natural selection acting upon these at the time.
These legs are far too small for walking on land, but they may have been useful while mating or for scratching away parasites and itchy skin.
I kind of wonder about that. Like, I do think there's a little bit too much emphasis placed on like, oh, well, here's how these atavistic traits might actually be useful. If they really were that useful, you would imagine that they would still be around. I don't know. I pictured this being like a truly vestigial thing. It was probably mostly, if not entirely, useless. But yeah.
Evolutionary theory tells us that the further we go back in time,
That's interesting, Mayor. Space
the harder it should be to distinguish whales from normal land mammals. Meet Myocetus. The hip bones of Myocetus seem sturdy enough to walk on land, but this animal is considered to be a whale for many reasons.
Yep.
Their skeletons have all been found among fossils of sea creatures, which tells us they lived in the ocean. Their short legs, combined with long, flat fingers and toes, suggest they were strong swimmers with webbed hands and feet. Here we see the bottom side of a Myocetus jaw and skull.
So well preserved, holy cow.
Her teeth match those of the basilosaurid whales we saw earlier, and the unique structures of her middle ear bones match those of basilosaurid whales and modern whales.
Oh, I want to... Sweetie pie, here, I can't see the keyboard.
Ear bones
I want to make this
those of basilosaurid.
I want to make this really clear for anybody who's a little bit confused about the layout here. What you're looking at is the underside of the animal's head right here. So that's kind of like, Sweetie Pie, will you be my model real quick? Here. You're looking at under like this. So there's the lower jaw right there. That's that kind of V shape right here. So here's the chin, and then here's the lower jaw. This is the throat, and then there's the teeth. So the eye is on the other side. You can't see it at this angle. And then those are the ears. And then here's the underside of like the vertebrae right there.
Whales and modern whales. Myocetus appears to be a walking whale. Scientists have found the fossils of many ancient whale-like mammals and continue to find more. Together, these fossils blur the line between four-legged land mammals and fully aquatic modern whales, solidifying the idea that whales indeed evolved from land creatures.
Yep.
Now let's look at a fourth line of evidence, DNA. DNA molecules contain chemical codes which act like recipes for living things. Without ever
That reminds me of is that DNA is God's recipe for making you. Oh, Sweetie Pie is looking at the cursor right now.
Have you ever wondered why fat parents have fat children? Or why Chinese parents have Chinese children?
The joke here is this is supposed to be like an old-fashioned newsreel that is like out of date and like mildly offensive. That's the joke here.
Coincidence. It's because of DNA. Hi, I'm Troy McClure. You may remember me from such medical films as Alice Doesn't Live Anymore and Mommy, What's Wrong with That Man's Face?
But Mr. McClure, what is DNA?
What the? Oh, hi, Billy. Let's find out together. DNA is God's recipe for making you. You take a dash of Dad, a pinch of Mom, then we bake for 9 months and... that's good, Billy.
Mr. McClure, what does DNA stand for?
Anyway, deoxyribonucleic acid is what DNA stands for. That's what all living things on our planet share. So by studying DNA, we can start to figure out how different critters are related to one another. And hang on a second. We'll get back to the video in just a moment here, but I think we just had a couple of Ko-Fi donation. Thank you. Holy cow. Joe Kennedy, the donation yesterday. Charlie's Dragon. You did not have to do that, Charlie's Dragon. Holy cow. Thank you for the contribution. And thank you, Niffler. Money for sourcing the rent to pay the land cat. Thank you, Niffler. I really appreciate that. Holy moly. Thank you for your generosity there. That is superb. Thank you. Good stuff.
Those contain chemical codes which act like recipes for living things. Without ever looking at bones, embryos, or anatomy, researchers can compare the DNA code of different living creatures to find out who is most closely related to who.
Yep. If you want more information about this, if you want to actually hang out with somebody who works on this kind of thing, someone who actively works on DNA in the laboratory, go follow Science Streams. Balint and Lita are both molecular biologists, systems biologists, geneticists. They literally work on this kind of thing, and they are far more informed about DNA, about genetics, about molecular phylogenies than somebody like me. I'm a fossil guy, you know? I'm a paleontologist. I'm a glorified ditch digger, you know? For someone who actually works extensively in the laboratory with things like DNA, for a true lab jockey, go follow science streams, because that's what Balint and Lita actually do. Yeah. And Frizzy Ostromy says, come on, paleontologists are worth gold. I like to think we're worth more than gold. But I'm trying to be self-deprecating here, Frizzy. Thank you for the kind words. But go follow science streams. They do really, really cool science outreach here on this platform. And if you're interested in science, they are a must-follow channel.
Whale DNA has been compared to all kinds of other animals. Fish, sea lions, you name it. And so far, the closest genetic match is to the pudgy, water-loving hippopotamus.
Yep.
This does not mean that whales evolved from hippos, but if this genetic finding is correct, whales and hippos both evolved from a common ancestor that lived roughly 54 million years ago.
Yep.
At first, the link between whales and hippos surprised researchers because whales are mainly carnivores. They eat things like fish and small crustaceans. Hippos, on the other hand, are mostly vegetarian. A closer look, however, reveals that hippos and whales actually share many strange features, some of which may have come from their common ancestor.
And so this clade that includes whales and hippos has a name, this group. Let me show you. We'll jump to that on our Tree of Life here. Yeah, Charlie's... Oh, Claire Burr's already got it. Well done, Claire. And Charlie's Dragon. It is within Artiodactyla, Neverwinter, yeah. So the Artiodactyls are the cloven-hoofed ungulates, also called the even-toed ungulates. So that's things like camels, llamas, pigs and their relatives over here, deer and giraffes and goats and stuff like that. But this clade over here doesn't say the name, but it is called Whippomorpha. That's a portmanteau of hippo and whale. Whippomorpha. There you go. So this is the whales plus the hippos. Really cool group.
Ancient walking whales have specially shaped ankle bones found only in hippos and the close relatives of hippos.
Yep.
Just like whales, hippos are known to give birth and even nurse their young underwater.
Mm-hmm.
They both have multi-chambered stomachs, which is common for herbivores, but is almost unheard of for meat-eating mammals.
Mm-hmm.
They are both missing a coat of fur. And here's a fun fact. Whales and hippos are among the only mammals on Earth that have internal testicles.
Yep.
So there you have it. 4 independent lines of evidence all tell us the exact same story. Whales evolved from 4-legged land mammals. But
Pretty
the history
neat, right?
of whales is not the only evolutionary history that we've been able to work out.
Yeah, birds are a kind of
Fossils,
dinosaur.
DNA, embryology, and many other lines of evidence that bird wings are actually modified arms and claws.
Yep.
Birds evolved from dinosaur-like ancestors.
Yes.
We can
have
also
emotes to
clearly
that
see
effect.
that bat wings evolved from 5-fingered hands, very similar to those of monkeys and shrews.
Yep.
We've found that humans share a fairly recent common ancestor with chimpanzees, that mammals evolved from reptile-like creatures. Those reptile-like creatures evolved from amphibian-like creatures.
And this always kind of irks me a little bit because I don't look at this and say, oh, that's reptile-like. That's a Gorgonopsian. It's a mammal ancestor. We used to call these mammal-like reptiles, but they're not actually reptiles at all. This is me, again, going, oh, well, actually, I'm being a little nitpicky here, but I look at this and I don't go, oh, that's reptile-like, because it's not. It's a synapsid. It's on the mammal side of things. But anyway, yeah.
Reptile-like creatures. Those reptile-like creatures evolved from amphibian-like creatures. Those amphibian-like creatures evolved from fish-like creatures. And fish, if you go back far enough, share a common ancestor with segmented worms.
Sure. All life on
So
Earth
to
is
sum
related.
things up, thousands of observable facts from completely independent fields of study have come together to tell us the exact same story. All living things on Earth are related.
Pretty darn cool. Here, there's only like a minute left in this video. I will give you a link if you want to watch the rest of it, but this is an excellent opportunity for us to take this knowledge, all living things are related, and bring it into Metazoa. So let's do that. Metazoa is our daily animal guessing challenge. And it provides an excellent opportunity to talk about phylogeny, how these different things are related to one another. So hang on a second, sweetie pie. I gotta put the keyboard here. Thank you. Okay. So, let's dive in, shall we?
On to your butts.
The way that this game works is there's a mystery species of the day. For Metazoa, it's an animal. For Metaflora, a different game that's related, it's a plant. But we only have to deal with animals here, which is kind of nice. So let's jump to animals on our Tree of Life here. There we go. And Frizzy Ostromy says, where are you based out of? Can you tell? I'm from the San Francisco Bay Area. So I live over in the East Bay, over there. But, yeah. Anyway, and our lights aren't working. It's always I need to figure out what's up with the lights. Anyway. Animals. We've got 1.4 million species here. Thankfully, there's not that many programmed into Metazoa. There's only a few hundred. But, we still have to try and figure out what the mystery species of the day is. And we use this... Well, we do this using that evolutionary family tree, that phylogeny, as we call it. I often like to start off with a mammal, because this game is heavily biased toward mammals. Mammals includes whales and people, and, yeah, mammals are creatures that feed their young with milk. They have bones. They usually have fur or hair. They're usually warm-blooded, but not always. Anyway, this game is heavily biased toward mammals, probably because it was programmed by mammals. Some mammal nepotism right there, but... Anyway, I often like to start off with a mouse. Mice are part of a particularly diverse group of mammals called the rodents, Rodentia. There's like 2,000 species of rodent. It's like 40% of all mammal species are rodents. So a mouse is a good place to start. Let's start off with a mouse and see where we get. Excellent. Pretty close. Not only is our critter a mammal, but like a mouse, it is a Boroeutherian. So that's the way that this game works, is you type in a guess, and then Metazoa will show you the most exclusive, the smallest evolutionary group that encompasses your guess plus the mystery animal. So with mouse, our critter's not a mouse, but it is pretty close, a Boroeutherian mammal. So let me show you Boroeutheria. We'll jump to mammals first. Mammals are over here. Then you have the Therian mammals, which are the marsupials plus the placentals. Boroeutherians are a kind of Eutherian, placental. There's the Boroeutherians there. So we know it's not going to be something like an armadillo or an elephant or an anteater, because these are not Boroeutherians. We know it's not a marsupial. We know it's not a monotreme. It is some kind of Boroeutherian. But we can tell even more than that, because again, we guessed mouse. And our critter's not a mouse. Metazoa says, nope, not a mouse. Best I can do for you right now is Boroeutheria. So, great. Because it's not a mouse, but it is a Boroeutherian, can look at where this group splits at the beginning. You take a right here, and you get to the rodents, the primates, and more. This is called Euarchontoglires. We as human beings are part of this group. But mice are a kind of rodents, so we know right off the bat it's not going to be a Euarchontoglire. Our critter is a Boreoeutherian. It's got to be a Laurasiathere over here. So already, with just one guess, we've been able to narrow it down from 1.4 million species to just 2,000. That's pretty good. It's pretty good. And Nasty Needle Boy says, San Francisco mentioned, let's go. Oh yeah, Nasty Needle. One more time. Actually, hang on. Let me, let's see if we can get the lights to work properly. Come on now. I don't know why it times out after a while. There we go. I was born and raised in the Bay Area and love this place. I've lived in a few other places in my life. I always find myself coming back here. Yeah. Anyway. So we know our critter is a Laurasiathere. This is the group that includes whales, too. Why don't we try a whale here? Whales are kind of artiodactyl. That's a good next place to guess. Let's go from... This is kind of funny. Going from mouse to blue whale. From one of the smallest, or smaller mammals at least, to one of the biggest, the blue whale. Really, the biggest, depending on how you count it. What's funny is there's a pun in the name of the blue whale, in the scientific name. I wonder if this is some arcane knowledge here, but I wonder if anybody knows this. What is the pun in the blue whale name? It's kind of a little joke. Some science humor there. I think it may have been Linnaeus himself who came up with this pun. Muscly says, I mean, that's it, yeah. Yeah. There we go. So the blue whale, its scientific name is... Well, here, let me show you the... There we go. Musculus is the house mouse. That's the scientific name for the house mouse. The blue whale's scientific name is Balaenoptera musculus. It is thought that that might be like a pun. It's like, oh yeah, you know, this enormous animal, yeah, we're gonna give it a mouse name, you know? Yeah. Nomenclature, there we go. The name Balaenoptera means winged whale. Well, the species name musculus could mean muscle or a diminutive form of mouse, possibly a pun by Carl Linnaeus. So anyway, let's guess blue whale. We'll jump from a mouse to a blue whale, and we'll see where this gets us. And interesting. Okay, it's definitely not a whale, but it is a Laurasiathere, which we already knew. Interesting. This is good. This is good. I think. Or maybe it's not. Shoot. Here's Laurasiatheria. So our critter could be a Eulipotyphlon. That's an early diverging group here. We know it's definitely not going to be an artiodactyl. There's a ton of species in here, so... Especially in Metazoa. These are overrepresented in the game. We know that our critter is not an artiodactyl, but it could still be... What are these? The Scrotiferans? It could be one of these guys. Let's try our luck over here. This is the bats and the carnivorans and the perissodactyls and the pangolins too. Yeah, let's try some kind of carnivoran. This is a group that is overrepresented in Metazoa. This is the lions and tigers and bears. This is the hyenas and the sea lions and the otters and the weasels and the etc. Let's try something like wolf. That's a good one to try. Let's see. And oh yes! Oh man, we got lucky here. Holy cow! Oh, sometimes you get really lucky in Metazoa. Our critter is a canid. It's a member of the dog family, but it's not a wolf. It's not a wolf. That does narrow it way down, Claire. Yeah, yeah. Excellent. So our critter is not just a caniform, it is a canid. Part of this family. So we're down from 1.4 million species down to just 34 now. But I think it might be a fox. Because here's the thing. We know it is a canid. Foxes are a group that diverge pretty early on. And then you've got the dogs and wolves and those critters over here. So, gray wolf and domestic dog. Jackals. It could be a raccoon dog, but I kind of doubt they have that. I bet you it's some kind of fox. Let's see what we got here. All right. Is it a red fox or an Arctic fox? I think it's going to be a fox. We've got two options here. So what I like to do when we've got a 50-50 chance is I like to leave that up to the chat. I like to do a poll. So let's do that. Which fox species should we guess first? Red fox, which is Vulpes vulpes, or Arctic fox, which is Vulpes. What is the Arctic fox? Bat-eared fox, Tibetan fox, split fox, Arctic fox, Vulpes lagopus. And here, I gotta get rid of those spaces because there's not enough characters in there. Let's just do V. Lagopus, so we don't have to butcher this. There we go. And do I have that right? Did I spell it right? Lagopus, yes. Excellent. V Vulpes, just for consistency's sake. Okay, and start poll. There we go. Yeah. Alright, Arctic Fox is catching up to Red Fox here. They are tied neck and neck, 9-9. Red Fox is pulling ahead, although they're back level again. Arctic Fox is pulled ahead. Let's see. I don't love it when it's neck and neck. I want there to be a decisive answer. But chat loves to, you know, make it a tie. And I shouldn't have done this as 2 minutes. I wasn't paying attention to the duration. Oh, goodness. I'm going to go run to the bathroom, and I'll be right back. Okay? We've got another minute. We'll see where we end up. Thank goodness. Okay. Not a tie. Arctic Fox won by 2 votes. Okay. Thank you for your patience there, chat. All right, we'll do Arctic Fox. Let's see here. You ready?
Hold on to your butts.
Arctic Fox. And... No, what am I doing? It's not just Canidae, it's genus Canis. That was completely... rookie mistake. Yeah. It's got to be within genus Canis, so it's either going to be a coyote or a domestic dog. Dog or coyote. Okay, well, let's do this again. Sorry. New poll. Dog or coyote? Let me show you how I goofed this up. It's the wrong genus. Vulpes is the fox genus. I was thinking this is Canidae, but no, it's genus Canis, which is over here. I was not paying close enough attention. Dogs, wolves, coyotes, and jackals are genus Canis. And we've got different species within this genus. Canis mesomelis is the black-backed jackal. Golden jackal, side-striped jackal are different species within this genus. And then there's the gray wolf and domestic dog are within Canis lupus. I don't think it's going to be that, actually. I think it's got to be a coyote. Canis latrans, because both the domestic dog and the gray wolf, and most modern phylogenies that you see, they're listed not just as the same genus, but the same species. Since domestic dogs literally evolved from gray wolves, they've been domesticated from gray wolves, they're literally the same species. So it's gotta be a coyote, right? Let's see. Coyote. You ready?
Hold on to your butt.
No? This is a little frustrating, because sometimes Metazoa is a little bit out of date when it comes to these things. Oh, they also have Jackal. Oh, shoot. Okay, let's try Jackal. That's it. I kind of assumed they wouldn't have Jackal, but they did. Anyway. Did it in 6 guesses. That's not the best. But, yeah. You've overthought Metazoa. I often do, Cozy Kestrel. Yeah. Anywho. Anywho, yeah. Jackals, yeah, there you go, Petrodactylus, yeah. Anyway. We all jackal things up every once in a while. It's true, Catkinsworth. It's true. Yeah. Anywho. With, we've got 58 minutes until there's a new Metazoa, and since I'm not streaming tomorrow, we might as well do that one too in an hour. But for right now, we've got a Diabloceratops skull to assemble. So why don't we do that? And yeah, maybe we will redeem ourselves. I will redeem myself, rather. I'm not putting this on you, chat. My fault. And thank you, Claire. Yeah. Yeah, so let's assemble our Diabloceratops. We've got a 3D printed skull of this animal. Just finished printing a little while ago. Oh, and this is now printing too. Chat, what do you think I'm printing at the moment, now that our Diabloceratops is done? What could this be? Any guesses? Sweetie Pie, again? What could this be? A car, says Techbird? A Batmobile? It's even cooler than that. I happen to be printing my very own car, and not... not just my very own in that it's my 3D print, but...
Wow!
My 2008 Toyota Prius. I figured it'd be fun to have a 3D print of this that I could put up on the wall. This is my field vehicle, and this is it leaving Doling's Bowl this year in the middle of the Utah desert. But yeah, this is my rough and tumble, hyper-capable field vehicle. The best field vehicle I've ever owned. Anyhow. Yeah. Sweetie Pie, you're going to have to get off the desk soon. I'm sorry, because there's going to be a big ceratopsid dinosaur skull that's going to be right here. Let's get that, shall we? Here. It's time to do some 3D printing. Or some 3D print assembly, rather. Here. Gotta prepare my workspace here. Towels at the ready for when the glue spills over, as it often does. Here's a bunch of our parts. And then, well, here's the skull over here. Fits in here as it is. It's gonna be tougher when it's all assembled. But let's do it. It's here for now. There we go. And this is life-sized, although the original holotype skull might not have been a full-grown individual. Sorry, things are hitting the soundboard. There we go. There we are. So the skull of this critter, the holotype, is at the Natural History Museum of Utah. Here it is with friend of the channel, Utah State paleontologist Jim Kirkland. He is lead author on this paper, along with the discoverer, Don DeBlue. This is not a huge individual animal. I'm not totally sure it was mature at time of death. It very well might not have been. But, yeah. We're going to go ahead and assemble this critter. In life, it would have looked something like... well, something like this. Yeah. So not the biggest animal, but not tiny either. There's a lovely illustration there by artist Laura Titan. Excellent. Anywho, really neat animal. Let me go get my Diabloceratops model too. I got one as a Christmas gift from iOS a couple years ago. Let me grab that. I will be right back. Keep an eye on the 3D printer while I go run over there, okay? Go. Yeah. Nifty little model here.
Dinosaur! Gigantic dinosaurs attacking our boy!
A dinosaur?
What?
1,000 bits can make a
hang on a
wonderful
second.
difference in promoting the appreciation
Sorry for the alerts. Here, let's
and understanding of fossil.
There we go. I can refresh the cache for our alerts. Anyway, really cool critter. So there's a reconstruction of what this animal may have looked like when alive. I'll put that over here. We can use that as reference, especially if we get a raid or something. Yeah. So let's assemble the snout, why don't we? The rostrum of this creature, the beak. And we are getting a raid. Well. There we are. Do we need to refresh it again? Sushi Cat. Sorry the alert didn't go off properly, but welcome to Paleontologizing. It is lovely to have you here. Here, quick little channel trailer as I get things together to assemble our life-size Diabloceratops skull 3D print. And here we go. How was your stream, Sushi Cat? Thanks for bringing everybody over.
My name is Danny
Appreciate that.
Anduza. I'm a dinosaur paleontologist, and this is Paleontologizing. Science isn't just test tubes and beakers and white lab coats. What we're doing out here is science, too. We're testing hypotheses by excavating these fossils.
Join me for museum tours, interviews with other paleontologists, audience Q&A, 3D printing.
It's pretty big. Who thought this was a good idea?
And of course, live dinosaur digs.
A limb bone from a new duck-billed dinosaur.
I invite you to tune in and experience the adventure of fossil science.
Welcome. It is great to have you here, Sushi Cat and Raiders. Thank you for joining us. We are assembling a life-size 3D print of a Diabloceratops skull right now. And it's going to be large. It's going to be quite large. So brace yourself. Here's those pieces. Let's put together the snout. So this is going to go right here. And then let's put this down. I said we would do this yesterday and we ran out of time. So we're doing it today. There we go. Just on there like that. That big honkin' window right there is the nares, the bony nostrils of this animal. Let's put that together. Glue. And let's use the super quick drying glue. 5 to 10 seconds glue. Perfect. And holy cow, off-kilter photo. Thank you for the 10 gift subs there. Really appreciate that. Holy moly, off-kilter photo. Sorry, our alerts are still a little squirrely right now. But thank you for the 10 gift subs. Really appreciate that off-kilter photo. There are 10 lucky chatters, and now won't have to watch a single ad on this channel for the next month. Thank you, Off-Kilter Photo. I really appreciate your generosity there. Excellent. Good stuff. Thanks for helping me board stuff like this. And this trip that I'm going to take to Utah starting tomorrow is not going to be cheap. I'm going to drive all the way there, and I'm going to a wedding, and got to pick up some stuff for the wedding. I've been asked to help out, so it's going to be a busy and probably kind of expensive weekend, but I'm really looking forward to it. I'm just going to score this a little bit, make sure that the glue has some texture to clamp onto. I want to do this right. If I have room in the car, I might even bring this with me to Utah. I think that would be a lot of fun. And since there's going to be a lot of other paleontologists and students of paleontology at this wedding, I think this will be an audience that will really appreciate this. There we go. Nice texture there. That'll work. Excellent. Focus this up. There we go. That's better. Nice. So that's the best way to do this. There we go. Let's do this first. So this is our premaxillary bones right here. Put in some Gorilla Glue. This is really nice as a gap filler, but it does take a long time to cure. So rather than having to hold this together for an hour all clamped like that, we've got a little trick. We use instant cure cyanoacrylate, super glue, and that acts as an accelerant here. It helps everything set up really quickly. So we get quick drying, and we get a nice firm hold with the Gorilla Glue. By itself, this can be a little brittle. The Gorilla Glue gives it a little bit extra resilience. You get the best of both worlds with that combo. Nice. There's that right there. We can let that sit. And let's put some glue on here. And there you go, Charlie's Dragon. Exactly. There we are.
Look at this graph!
What a beautiful graph. Delete the radio. Thanks for the follow. Welcome to Paleontologizing. It's good to have you here. Lovely. I'm glad you like that alert, Frizia. Yeah. And how much glue does a dinosaur eat? Well, a fair amount, if we're talking about this one in particular. There we go. There's our nose. Little incipient nasal horn right here. Little baby nasal horn. Yeah, not too shabby. Excellent. So, our nose right here. This is pretty big schnoz. Significantly bigger than mine, but here's the nostril. Yeah. Yeah. And the beak, because this animal did indeed have a beaky beak right there. Let's attach that. What we call the rostral bone. Ceratopsian dinosaurs. I've got a special bone forms that beak. It's called the rostral. There we go. So on a ceratopsid like Triceratops here, It's got, there we go. Bingo. The rostral, part highlighted in red right there. It's really long on Triceratops. It is shorter on this much earlier ceratops, a much earlier horned dinosaur, Diabloceratops. See how short it is right there? Compare that to Triceratops, where it's much longer. The rostral for this guy is right here. So let's stick that on the front. There. Just like this. Lovely. Beautiful. Yeah. In life, that rostral would be covered with a layer of keratin. That's the kind of material that our fingernails and hair are made of. The beak of a parrot is also keratin like that. And you can see this kind of scraggly texture. We call that rugose. R-U-G-O-S-E. Rugose texture. That is often an indication that keratin would have been attached to this in life. So, hope that makes sense. You see this kind of texture on things like horns and beaks, on the bony part of it. The keratin attaches at the top. And you also see it on things like stegosaur plates. Same kind of deal. So I'm going to use a lot of Gorilla Glue on this because it's pretty gappy. There's going to be a lot of gaps. So we're using a lot of Gorilla Glue as kind of gap filler here. And then the super glue will seal the deal and help all that stuff set up so it doesn't take forever. Yeah. So like in bird beaks, this would be like likely eating something different than Triceratops. Yes and no. So it would be eating different plants than Triceratops because it lived like 20 million years before Triceratops. When is Diabloceratops from? There would have been different plants alive at the time. But I don't know if it really connotes like a different kind of diet. It's just like there would have been different plants alive at that time. So it's from the Wahweap Formation. What is that? Yeah, about 81 million years ago. So Triceratops lived about 67 to 66 million years ago. So, yeah. We're talking about a difference of like 15 million years. So, there would have been a lot of changes in the flora in that time. But it doesn't necessarily mean that they're eating like different... They didn't live at the same time, so of course the plants would have been different. But I don't know if that's why the beaks look different. I think it's just these animals tend to develop larger beaks over time as these lineages continue to evolve. So I don't know if that necessarily connotes a different diet. Does that make sense? Yeah. And there we go. There's that beak on there. Nice. Very nice. Lovely. I'm going to make sure that it's kind of centered laterally from side to side. That's pretty good like that. Yeah, superb. Excellent. Yeah. And Lapdog Millionaire says, I wish gorillas was actually a unit of glue strength. Yeah. That would be interesting. How do you quantify glue strength? That seems like a tricky one. How do you put a number on that? Anyway, very nice. This is looking excellent. How's that for a schnoz? Pretty good. I guess it would be like this. Excellent. Let me look at the instructions here because a 3D print is going to be, you're going to assemble it a little bit differently than you would assemble an actual skull of this animal, just based on how the files are put together. So let's take a quick look at the instructions and see where they recommend, when they recommend these different parts be put together. Let's see. Alright, so it kind of wants us to put the maxilla and jugals and the vomer and the palatine and all that together first, and then stick this onto the front right there. So let's do that. Oh, we got some other glue over here. Let's clean that up. There we go. Nice. Yeah. And get from glues into things like epoxy, etc. So Special Agent Bob. Different environments. Yeah, that makes sense. Yeah. I've used epoxies before. They tend to take a really long time. I'll use JB Weld or other two-part epoxies for stuff. And there's a specialized kind of epoxy that I use all the time on 3D prints in order to smooth them. So sometimes 3D prints will have these layer lines on them. And you can kind of see that here. It's our manual focus. If you look real closely, you can see those striations going this way across, like right there. See those lines? That is just how 3D prints work. These things are being laid down layer by layer by a 3D printer like this. And so it's just kind of inherent to it. I've got a really small nozzle, a 0.25 millimeter nozzle on my printer right now, and so the layer lines tend to be really small, but they're still there. So often I like to hit them with a two-part epoxy smoothing compound. And I'll also fill in these seams. Like you see this line going across right here? See, that's perfectly straight. That doesn't look natural. It's not. This is the premaxillary bone right here. And that is an artificial line going across it because it was too big to fit on the print bed of the printer. You gotta break it up into different pieces to be able to print it. So I'll hit this with some water putty to fill in that seam, and then I'll smooth it out, and then you'll put the smoothing compound over the top of it so it blends nicely with the skull. Does that make sense? Yeah. Something. There you go, Frizzy. Yeah. And layer. There you go, Kathleen Smart. I've also heard them called 3D print lines, but I think layer lines is the more official term. And it will be beautiful. It's going to be awesome, TechBird. It's going to be awesome. I can't wait. All right, let's put together the upper jaw, the maxillary bone, and the jugals and all of that. So I'll set this down here for now. But first, let me show you what that looks like on a person, because you also have maxillary bones. Most of these same bones we also have on our skulls, too. We don't have a rostral bone because we don't have a beak. That's a special thing that this group of dinosaurs evolved. But, there we go. Human skull, in parentheses, exploding by Whitmer Lab. Here we go. So these are all the different bones in our skull. I think a lot of folks, they kind of assume that when we're talking about a skull, they're like, oh, the skull is one bone, right? And, no, not right. That's totally wrong. There's many different bones that make up the skull. Pause. Okay. So we've got the nasals, we've got the, I guess our frontals and prefrontals are kind of combined in a human skull. The mandible is down here. Mammals only have one, mandible on either side. The other jaw bones have been shunted up to form the inner ear. We've got the parietals and the squamosals back here. But then anyway, the maxilla is this bone right here that has the teeth in it in the upper jaw. So this is the maxilla right here. That's what we're gonna do next. Here's what it looks like on our ceratopsid dinosaur. So here is the left maxilla right here. So this side of the face with the teeth. Is that right? Is it right? No, sorry, this is the right maxilla. What am I saying? It goes on this side. As you can see, here is the lateral side of the teeth. And here's the lingual side, the tongue side. Oh, yeah. Like that. So we're going to put together this part. Right maxilla and lacrimal. Let's put those together. The lacrimals, those are the bones here. So like on the inside of the eye, essentially. So on our human skull, lacrimals are gonna be, those are the nasals. I'm so unfamiliar with human cranial anatomy. It's so much weirder than dinosaur anatomy is to me. Lacrimal bone. There it is right there in us. And there it is on the Diabloceratops too. It's the anterior part of the eye. The front part of the orbit, the eye socket. There we go. There's the lacrimals. They look like this in this 3D print. And this is literally the same bone. It's a homologous structure. So it's the same bone in humans as it is in dinosaurs like Diabloceratops. Our ancestors, you go back far enough, humans and dinosaurs share a common ancestor. You gotta go back 300 plus million years to get to that ancestor. So in the time since then, these have been evolving in separate directions. That's why they look so different. Yeah. But it is literally the same bone. That's gonna go there. Cool. It's gonna be a little tricky here. I'm gonna score this a little bit with our hobby knife. Just give the glue a little something extra to cling to. A little bit more texture there. So I'm working against those layer lines. And then we'll cross hatch it like that. Lovely. And then this is going to go on here just like this. There we go. Let's do the same thing on here. Give it a little bit more texture. I would sand this, but that takes a long time and it generates a ton of dust, and I really don't want to be breathing that in. So I found that this tends to work a lot better. And then this is also going to be an occlusal surface. We'll just rough this up a little bit too. That's probably good enough. It's going to go on here just like this. There we go. It's like this from the other side. Lovely. And it does so much for adhesions, especially in Bob. That's what I found, yeah. Yeah, it's... And that's kind of a recent discovery. I realized rather than spending a ton of time with sandpaper or a sanding stick, instead you just do that and it helps a lot. So I'm a little bit leery about this because there's a few different angles that I could put it on. But I feel like if I just kind of split the difference, that should work. Hopefully I don't eat my words here. Let's hit this with some Gorilla Glue. It's probably too much. But we've got paper towels to sop up the excess. Just a little bit of Gorilla Glue, super glue here. Moment of truth. It's about good like that. Hold it together for a little while. Let that start to set. It feels good. It feels like it wants to be right there at this angle. Wet sanding. That's an interesting idea, especially for Bob. Yeah. And yeah, it is BSI. Yes, indeed, TechBird. I've been using this stuff for a long time. I discovered this when I lived in Montana. They had a special kind that it was so, at least they claimed it was so non-toxic that you could actually use it in a fish tank. The idea was that it was almost special for like an aquarium application. Neat stuff. Yeah. Anyhow. Excellent. We got that right there. Now let's do the other side with the other lacrimal. I'll let that sit for a minute. Here is our right maxilla, our right upper jaw, right here. Yeah. So let's score this. One thing that I've noticed is that sometimes when you've got really good adhesion between different 3D printed parts, it can sometimes be a little too much. Like, say something unfortunate happens, a shelf breaks, or someone you're asking to help you drops one of these 3D prints on the ground, and it breaks. Sometimes if you've got really, really good adhesion between the different parts, that means that rather than breaking here at the joint between two different parts, rather than the model snapping right there, kind of where it's supposed to, instead it might just snap down the middle of one of these whole parts, and so it's like, oh shoot. Almost like when you get a little too excited and you try to open like a cereal box, and rather than like opening it where it's supposed to open, the top just tears off or it comes in half or whatever. I've had that happen before, where I glue things a little bit too well, so if something goes wrong, it doesn't break where it's supposed to, and that can be a little unfortunate at times. But yeah, sometimes you're a victim of your own success there. It happens, but not the worst. It's like when you're wearing a hat that's too tight, and you try and pull the hat off, and it takes your head with it, your neck just rips, and then your head is detached from your body. Don't you hate it when that happens? you know? That's kind of what I mean. Yeah. Pretty unfortunate, exactly, Laptop Millionaire, yeah. There we go. Wait, what? Did I do this wrong? I did. Shoot, this goes right here. That's okay, we'll have to score that other part later. But let's do that right here. This is already kind of layery, so I think we're gonna be okay. I don't have to worry about scoring it too much. We've already got pretty decent texture. Let's just glue it. And Turgis, the orientation of the layer lines, exactly. Yeah, I've actually found that with a smaller nozzle on the 3D printer, like I've got a 0.25 millimeter nozzle on the printer right now, it does make the print stronger than when you've got a larger nozzle, larger aperture. Yeah, things certainly print quicker, but they are a little bit less strong for sure. Worse is when the spinal column comes out all Predator style. Exactly, Special Agent Bob, yeah. If your spine is just too strong, I hate it when that happens, right? Alright, I should have test fitted this first a little bit better. That's okay, we'll make it work. There we go, nice. Lovely. Ah. Cute. This one's a bit more finicky than the left maxilla and lacrimal. But that's okay. If we have to redo it, we can redo it. An interesting cozy kestrel, that's neat. You know, I did a Velociraptor a few years ago. Have you seen that? You've seen Velia, right? My life-size Velociraptor that I brought to TwitchCon for the past 2 years. An interesting Turgis. Printing temps and cooling speeds affect strength too. I've not really gotten into the weeds on that. I tend to use the standard temperature for these things. But with the slicer program that I use, Prusa Slicer, it has kind of settings, preset settings for different for different 3D printer filaments. So like for this, I've got the settings for Hatchbox filament, which is the brand that this color is. But there's also, I don't know if they have one for Overture. I found that the Prusament settings work really well for Overture filament, which is what this is. This is Overture brand filament, which I feel like it wasn't very good to start with when I tried it years ago, and now it's excellent. And different colors are going to have different chemical compositions, and they'll be better or worse. I guess all this stuff kind of comes with experience. But, oh man, this really doesn't want to stay. Okay, what goes right here? Let's check on that real quick. That's going to be the... Now is not a good time, sweetie pie. I'm sorry. Hey. Not a good time. Not a good time. There's other stuff in the house to go see and do right now. I'm sorry, I can't have you up on the desk right now. Lacrimals... Quadrates, right? No. Well, that's gonna be tricky, because I didn't print the hinge yet. There's an extra piece that you're supposed to print to attach the lower jaw, the hinge, And I guess you're supposed to put that on in advance of printing the lower jaws. Or assembling the lower jaws, and in advance of attaching the quadrates. So I might have to attach the quadrates just loosely so I can pull them off later and redo this. That's what I'll do. That'll work. Yeah. TechBird says Prusa Slicer is great. I'm glad you think so, because that's the one I've always used, and I've been pretty happy with it. Oh man, I need to pull this apart now. I didn't put enough super glue on here. It's not sticking the way it should. Let's redo this. Take two. There we go. Sometimes condensation from your breath helps it set up just a little bit better too. There we go, now that's going. I'm more confident about that now. I miscalculated, didn't put enough super glue on. That should do it though. Nice. Alright, now we're going to attach, there we go, the palatine to the pterygoids there. And I think I already did the brain case. I did. So now it's time for the pterygoids and palatine and vomer. The vomer is a little thin bone. I guess it's vomers. They're paired, but they're fused here. We've got the same thing in us people. The vomers are right there, I believe. And then the palatines and pterygoids, where are those? Give me a second. What's up? There we go. The pterygoids are... Oh, is this one of those things where they've got a different name in people? Oh, goodness. What do you call it in human anatomy? The pterygoids are muscles. I guess the actual bones have got a different name in human anatomy? Who knows? But the vomers are right there. They're extremely thin. But you can kind of see it in the nares, in the nasal cavity in people. There we go. Looks like that. Yeah. So let's get that glued together. There, vomers, pterygoids. There we go. That's this. This is gonna go on here like this. No, like this would make more sense. Yeah. Check. Da-da-da-da. Yeah, there we go. Yeah. Let's attach that. And with this, we're just going to use super glue. I don't think we need a ton of gap filling. It's going to be something I just want to set really quickly. And it's okay if it's a little bit brittle. Not the end of the world. Should be fine. It's nice and straight, looks good. Just gonna hold that there as it sets. Yeah. And is it the sphenoid? No, because we also have a sphenoid in dinosaurs and other vertebrate animals. They're tetrapods. I think... Here. Ah! Gosh darn it. I'm getting impatient. I should have held this together a little longer. Anyhow. Pterygoid bone. I guess there's pterygoid processes of the sphenoid bone? Pterygoids might not... Mammals may have lost that? I don't know. Anyway, it has to do with, like, the way that the jaw articulates to the skull. It's, yeah. Anywho, this is about done. That's feeling nice and sturdy right now. So that's the vomer right there, which kind of forms the roof of the mouth to a certain extent. It's part of the roof of the mouth. And then attach those pterygoids. And here. There we go. So, just like that. I already scuffed this up a little bit. Should be okay. We'll just... Well, this is important. Let's be patient and do things correctly. Find my knife. There it is. Set this aside. This is pretty thin right here. There's not a lot of surface area to grab onto, so it probably is pretty important that we're adding this extra bit of texture. That's nice. Here too. Although the print lines here, the layer lines, are offering some texture, which is nice. Don't have to worry too much about this. It already feels kind of rough. But on here, this is really smooth because this was up against the print bed, up against that metal plate on the printer, the substrate. So, it is too smooth. So let's carefully score that. Give it some texture. Feel more confident about that. That's good. Yeah. Good enough. Let's attach these. So let's just go on right here. Says so satisfying. I'm glad that this is enjoyable to watch. It's gonna go on just like that. In fact, let's test fit that real quick. Looks good. Super glue. Go. There we go. Lovely. Excellent. Hey, Semi-14, howdy, howdy. Beautiful. Got a good fit there. I just gotta hold this together for a minute. Oh, this came loose. Gosh darn it. I have to re-glue that. That Vomer is gonna give us trouble. And Special Agent Bob, print files out there for an Elasmosaurus skull? I've been looking for one for a while. I don't think there are any that are available for free. I do have some friends at the museum in Pocatello, Idaho, who have a 3D printed Elasmosaur skull. And I'd love to be able to ask them if I could get hold of those files to print one. There is a sculpt that I found online, but I'm not sure how accurate it is, and it does cost money to purchase. But yeah, Elasmosaurs have really cool skulls, and I would love to be able to print one. I think that would be really rad. But it hasn't been super high on my priority list, I guess. Yeah. I've already got a big backlog of other things that are more relevant to my research interests and my outreach and everything. An Elasmosaur skull just looks really cool, but it's not... I gotta put some more super glue in here. Gosh darn it. It's just not super relevant to what I do. Oh, actually, come to think of it, there is that Elasmosaur from New Zealand. He's got the really cool... I gotta pull this off, too. It's annoying. We'll do this in a minute. But there's that Elasmosaur from New Zealand that's got a name. I think it's a Maori name. Starts with a K. There is a file of that skull, but it's all crushed. It's flattened. It looks cool, but it's not like a 3D skull. It's squashed flat. I have that file. You can find it on Sketchfab. It's like Kaukia Mehua or something like that. I can look it up in a minute. I know I have the files, but I gotta hold this together for right now. Yeah. There we go. That's starting to set. And I don't actually know the name off the top of my head, Claire. It starts with a K. If you look up... it's a longer name than that. Give me a second, and I'll actually find the files. But I gotta hold this together for right now. There we go. Alright, let's do this one. And then we'll go back and do the Vomer again. Reattach that. Thank you, Anonymous Gifter. Gifting Special Agent Bob. I appreciate that. Thank you kindly, Anonymous Gifter. You are as generous as you are mysterious, and I appreciate you for it. There we go. There we go. Got those pterygoids on there. Lovely. Alright, holding these in place. And it's not Mauisaurus. No, it definitely starts with a K. I think it's from New Zealand. I think this will stay. Here's an Elasmosaurus skull scan that is not available for download. It wasn't Kaikaifalu. Kaikaifalu is a mosasaur, I think. I know I've got the files downloaded. Let me look at my 3D printing folder. Kaiwakea, I think? Kaiwakea. There it is. Bingo. Yeah. Yep. That's it right there. Yeah, so it is squashed flat. So it's not the prettiest. But it is available for download for free. There's a link in the chat for you. It is really cool for sure. Yeah. Yeah. But I want to ask my friends at the museum in Pocatello whether I could get hold of their Elasmosaurus skull files, because those are really pretty. And they've done a lot of post-processing on them, so they look really nice. Alright, let's put this Vomer back on. Right here, right? Do I have this right? I don't? Go like that? Hang on, how does this orient? Yeah, okay, it goes like this. Good. Alright, let's do that. This is a tricky one. In fact, let's put a little bit of the Gorilla Glue on there, just for good measure. It turns out, I guess, neither of these by themselves are all that strong. It's the cocktail of the cyanoacrylate and the Gorilla Glue together. It's the real winner. A little bit of moisture there. There we go. Now I just gotta be patient and hold this here. Wipe off some of the excess. That might decrease our curing time too. There we go. Lovely. And those weird elasmosaurs are almost filter feeders, right? I think they may have been, Dr. Terra. Kind of like a crab eater seal. Which, oddly enough, don't really eat crabs. They are mostly krill eaters. They mostly filter feed, as I recall. I think that's the closest living relative of the leopard seal. They're cool critters. But they've got weird teeth that are all complex, and they're kind of like a sieve. So, yeah. And Dean Feeney Music, hey, I'm putting together a life-size Diabloceratops skull. These are some of the weird, spindly bones up near the roof of the mouth and back near the brain case. But you'll see. And yes, leopard seals also eat krill, yeah. So both they and the crab eater seal, was inappropriately named. I don't think they really eat many crabs. They evolved from a common ancestor that probably evolved to eat krill. Leopard seals became more generalists, and I think crab eater seals kind of stayed on the krill eating train, so to speak. There we go. Nice. I will set this aside for now and just let that set up. There we go. Yeah. But here, let's get rid of some of these tabs. Oh yeah, I'm 3D printing a Diabloceratops skull, life-sized. Here are friends of the channel, Papa Jim Kirkland. Dr. Jim Kirkland is the state paleontologist of Utah. He discovered and named dinosaurs like Gastonia and Utahraptor. And here is Assistant State Paleontologist Don DeBlue, who discovered Diabloceratops. This is his baby. And Don will be retiring at the end of December. They're currently looking for a replacement for him, and that is a tall order. Not many people in the world like Don. Yeah. And Dean Feeney says, how big were their brains relative to body size compared to humans? A lot smaller. So dinosaurs, kind of like birds, were more efficient in terms of their brain to body ratio. They could do more with a smaller brain, so to speak. But at the same time, these wouldn't have been the most intelligent animal in the world anyway. But they were intelligent enough to succeed in their environments, and yeah, that group really diversified. Hugely successful group, the ceratopsid dinosaurs. There's so many different kinds of them. Where's that image? One I really like with the... Here we go. Beautiful. Look at this image right here. With all these different sizes and shapes of ceratopsian dinosaur, mostly ceratopsids. Huge diversity in their cranial anatomy. And Diabloceratops is the blue guy right here. Yeah. So that's the one we're assembling right now. And Special Agent Bob says, I wonder if some dinosaurs could be calmed down with a hood, the way hawks and falcons can be. I mean, people are the same way. Yeah. Yeah. And Dean Feeney says, I didn't know there were so many variants. This is not even all of them. There's so many different ceratopsian dinosaurs. Just within the Ceratopsidae, the family of the big horned dinosaurs, there's a bunch of different genera and species. Here's just a few of them on the wall at the Natural History Museum of Utah in Salt Lake City. There's Diabloceratops in the bottom center there. See it with the parietal horns going out to the sides like that? That's Diablo there. Do we have a list of ceratopsids? I don't know if we do. Yeah. Anyway, there's a whole bunch. Within the Chasmosaurinae, this is one major group. You've got all of these different genera and species. Look at all these. And then the other side, you've got the Centrosaurinae. And you've got all of these over here, from Brachyceratops down to Pachyrhinosaurus. There's quite a few. So, diverse group. Anywho. So let's see here. Let's put the jugals together, and then we'll start assembling some of the larger pieces. Oh, also, let's put the well, we'll do the maxillae in a minute. Let's do the jugals. So the jugals are the cheek spikes or cheek horns. So when a dinosaur like Diabloceratops, that's this part right here. So they've got these kind of jowly bits that stick out of the sides. Pentaceratops, the 5-horned face, those are horns 4 and 5, is these. They're sometimes called horns, or jugal spikes, but yeah. Jugal boss, there you go, Alexander, yeah. So let's put those together. They are going to be here. So... Is that right? I don't think so. I think it goes on here. I can tell my left from my right. There we go. That is correct. This is just a flange that sticks off the side. It's a little vulnerable if it gets bumped, so I'm going to score this really well. Make sure the glue really has some texture to cling to. There we go. So this had printed from this part up on the printer, so this is super smooth here. This was in contact with the print bed. We don't want that to be smooth. We want it to be nice and textured. That's why I'm doing this. Turn it and go the other direction. Cross hatch it here. Also do that on the inside of that divot there. Little concavity. There we go. Nice and rough. Excellent. Put this right here. That'll be lovely just like that. Beautiful. All right, let's do it. This is already nice and rough, so I don't have to worry about that too much. Planning to create the end of Oak Street. I have not seen it yet, Cirque. I've been super busy, and this weekend, basically like for the next 4 or 5 days, I'm on a trip to Utah to go to a friend's wedding. A friend who is currently working on a new kind of ceratopsid dinosaur that we just dug up this past summer. We just collected it from Wyoming. He's been sending me pictures of it in the lab, and I am super excited. It seems to be like a lovely in-between, a transitional species, so to speak, linking Triceratops and Pentaceratops before it. So anyway, there's a chance I might get to see the movie tomorrow or Friday? Otherwise, it'll be next week, maybe. But I do want to talk about it on stream, yeah. But I haven't seen it yet. Special Agent Bob says, if any birds are capable of existential crises, it has to be some kind of corvid, or maybe a psittaciform. The parrots and their relatives are also extremely clever. They are really brainy birds. People argue about what is the most intelligent bird, and it's a tricky question. It's like, how do you measure that kind of thing? But some of the best problem solvers are indeed parrots and their relatives, along with corvids and, yeah, smart birds. Now I'm imagining a depressed parrot because it's outlived its owner. They do that. They do that. They can literally get depressed or over or understimulated. That's a thing. Those birds are... They've got impressive brains. And they're highly social animals. In much the same way that corvids are. Yeah. They plug rubber and lining off vehicles. Yeah, famously Kias do that in New Zealand. Not Kia the car, but Kia the bird. K-E-A. But I betcha there's at least some instances of Kias the bird pulling apart Kia the car. It's kind of a funny thought. Yeah. Alright, 1 juggle down, 1 to go. Let's score this, and then get that glued onto there. Yeah. I trust the bird more, says J-Rock Magoo. A decade ago, I'd probably still agree with you. But Kias used to be really lousy as vehicles. They've gotten a lot better in recent decades. I remember my dad had a Kia really briefly. He had it for like a few weeks, I think. We may have just borrowed it from our Uncle Jose. But, from his brother-in-law. But it was so cheaply made, and the materials were just so low grade that I remember at one point he put like a coffee tumbler, like a plastic coffee mug, on the roof of the car, and it went gunk. It dented down. A coffee cup was enough to like make it go thump. It was just so cheap and flimsy. I don't think they make them quite like that anymore. I think they're a bit higher quality. But man, they used to be about as cheap as you could get. Yeah. The best bang for the buck still is Subaru and Honda families usually, though, says Special Agent Bob. And Toyota, too, in my opinion. I know people say that they're a little pricey, but you're getting quality with that. I think the cheapest vehicle to own long-term is still something like a Corolla or a Prius. I don't know, I've got 200,000 miles on my Prius. And very, very, very happy with it. A nice tech bird. What kind of 3D print are you putting together right now? Yeah, an 07 Camry. That's a great vehicle, Alexander. Absolutely. Yeah, you take care of that. With a little luck, it'll run forever. Yeah. Mitsubishi, interesting aerospace. Used Mitsubishis. I've never actually driven a Mitsubishi. If you read Dinosaurs of the Flaming Cliffs by Michael Novacek, he heaps praise on the Mitsubishi off-road vehicles that they had there in the Gobi Desert of Mongolia. Because on doing that kind of field work out in Mongolia, they had Mitsubishis, and they had these old Russian vehicles produced in the Soviet Union, like gas trucks and stuff. And those were just constantly falling apart, pieces falling off of them, the engines going, breaking down just constantly. You would curse them to no end, but the Mitsubishis were comparatively bulletproof. Super reliable. It's maybe not a fair comparison, but yeah, Mitsus, they call them in the book. They loved those cars. Yeah. And the Lada mentioned. I don't think it was Lada in particular. These were like Gaz trucks, G-A-Z, and stuff like that. Here, let me pull up a clip from that. Because there's an associated documentary. There we go. Bingo. Let's see.
But Andrews found one more thing. mud.
So this is in the 1920s.
Miles an hour. Rocks, ravines, washouts, and ditches followed one another in rapid succession. One might imagine that the roads have gotten better. They have not. And even modern Jeeps aren't built for a desert like the Gobi.
Especially not if they're modern Jeeps. Talk about trash. Just empty every pocket. Anyway, this is not a Jeep brand Jeep. I think this is a Soviet-built thing.
We have an electrical problem, and we don't know what it is. It's not a very complicated wiring plan. A Russian Jeep. It's not like a Japanese or American car.
You know what this reminds me of? Put it in H.
She'll go 300 hectares on a single tank of kerosene.
What country is this car from?
It no longer exists, but take her for a test drive, and you'll agree. Zagreb Ebnem Zlotik Diev. Put it in H!
There are...
again. Up with the N is backwards.
It's not a very complicated wiring plan. A Russian Jeep. It's not like a Japanese or American car.
Existential Noob, thank you for the follow, and welcome to Paleontologizing. It's good to have you here. Yeah.
They're up and running. But next, it's a truck's turn.
Piston, huh? We think it's piston number 6.
A critical breakdown could have severe consequences.
End of the expedition, if not the end of our lives.
Maybe we'll make it. Oh, God.
With the nearest gas station some 500 miles away,
sounds like
and time already getting tight, things will have to go smoothly from now on.
Oh, we're having some mechanical problems. We think it's a fuel pump, but we're not sure.
This could be way bad. Could be.
It seems to me I got this thing in there without doing the twisty deal.
Maybe we'll tow it or
abandon it.
Abandon it. Get on with it.
We can't stay here more than a day.
After more than 12 breakdowns, the vehicles all decide to run at the same time.
You can imagine the documentary film crew being so frustrated where they're like, they probably got footage of each and every one of those 12 breakdowns, and they're like, this is just too long. Just have to cut most of them out in order to keep the pacing of the documentary going, you know? Think of all the footage that was left on the cutting room floor.
As they enter the dusty dinosaur fields of the Gobi, they're traveling a long way, backwards in time.
Here is a link if you'd like to watch the rest of that. This is one of my favorite dinosaur documentaries. I remember watching that in the field with Denver Fowler and co. when we'd get rained out from field work. So if it's a dinosaur fieldwork documentary that dinosaur paleontologists are watching in the field, you know it's good. Yeah. Anyhow. There go Finder Keeper. I'm a new chatter. Welcome first time chatter, Finder Keeper. Good to see you. Yeah. And that's interesting. Search on 2CV Sahara. I've never even heard of that, Mayor Space. What does that look like? And apologies if I'm mispronouncing that. That's quaint. That's really funny looking. Oh, man. Wild. And Eddie indeed says Soviet cars were top-notch. Those had material in them. Here in Hungary, there's still a lot of racing events. That's the thing, is that, like, it was kind of like the Soviet approach to engineering, where it's like, it's as stripped down and easy to produce as possible. No bells and whistles, no air conditioning. They would have features like, power headlight and full floor. Things like paint were extra add-ons. There is something, I think, kind of beautiful and charming about that. I really like an ultra, simple, stripped-down vehicle. No extra stuff. You want extra, you add it yourself. There's something kind of beautiful about that. And I used to have a vehicle kind of like this. I had a 1988 Suzuki Samurai. That looked almost exactly like this. Yeah. Although my seats were not this nice. But it was the ragtop. I had a little bit of a lift on mine with larger tires and a souped-up engine. Little 1.3 liter engine. Little 4-cylinder, but it was lovely. Probably the best off-road vehicle I've ever driven, but man, it was not fun to drive at highway speeds. That thing didn't want to go above about 50. It did not like doing that. 50 miles per hour. But yeah. And yeah, old Suzuki Samurai, I miss that car. I bet you I can find a picture of it, actually. Mine in particular. There we go. Yeah. There it is in the Museum of the Rockies parking lot. This is circa 2013, 2014. Yeah. This is so much fun. I painted it myself. Spray paint. That's the lovely thing about having a dirt-colored car. When it's the same color as dirt, you never have to wash it. I didn't once wash it the whole time I owned it. Swift, Robert, there you go, Crimson, oh boy. And this is before I put the bull bar on the front with the winch, which made it, I felt like that doubled the weight of the vehicle. Image in new tab. A photo of it. Here it is covered in snow. After I put the bull bar on the front. Yeah. Let's see. There's my license plate. All covered with mosquitoes. This is in the field. Back then I didn't know how to properly wind up a winch, so excuse the messiness of the cable there. Let's see. Yeah, later on... Oh. I guess, is that it for pictures of the samurai? Shoot. Later on, I got an FJ Cruiser. And this was way too big, way too fuel efficient. It was really comfortable on the highway and everything, but it wasn't the greatest in off-roading because it's just too big. You can't really see over the hood. Excellent vehicle, reliable, but like just too big, too expensive. It was a little ridiculous. But yeah. Anyhow. Let's get back to our Diabloceratops here. Yeah. And thanks for being here, Special Agent Bob. I will see you later, I hope. Have a good week. We've got these components all put together. We just gotta now assemble these different assemblies. First, though, let's finish up our maxilla. The last of our, like, small pieces to put together. So we couldn't fit a whole maxilla on the print bed, so we had to kind of break them up a little bit. So let's put these on like that. Puzzle them parts, exactly, Alexander. Yeah. And interesting, Eddie, indeed, yeah. I think Suzuki kind of, they have a reputation for being pretty affordable. Not too complex. Thank you, Zephyraz, for the follow. Welcome to Paleontologizing. Good to have you here. Alright. This is going to go on like this. Lovely. Let's seal the deal with that super glue. Beautiful. Very nice. This is going to be one of those big gaps that I'll have to fill with water putty, but that's okay. There we are. Nice. Maxilla with those teeth right there. And now we'll do the next one. By the way, Eddie, indeed, if you're from Hungary, and if you speak Hungarian, have I already told you about Science streams? Do you already follow Balint? You probably do. I've probably mentioned this before, but in case I've forgotten, definitely go follow Balint from Science streams. I'm sure he'd be happy to speak a little Hungarian to you live on stream. Excellent. Looking good. Beautiful. A little bit too much glue, but that's okay. Better too much than too little. Lovely. Herb. Just let that set up there. And, we're looking good. We've got all of these pieces sitting around right here. Knocking things off the desk. Let's assemble them. So I'm going to put this way up here. what's the best way to do this? Here, I think, looking at the assembly instructions, it wants us to put the maxillae, wants us to attach those to the palatine and pterygoids and vomer. So, these, I'm putting them together like, that's not right. Other way. There we go. That's gonna go on there like this or like this. Hang on a second. I'm all turned around here. No, that's backwards. Sorry, having a bit of a brain fart at the moment. Bear with me here.
They were finding fossils.
Teef2, thanks for the follow. Welcome to Paleontologizing. Good to have you here. There we go. Like this. That's how it goes. Okay, excellent. Just like that. Beautiful. Okay. So what I'm gonna do is put some glue in here. Let's do that. Just to start with, and then we can add some other glue, because it's hard to see where these different pieces are actually going to fit together. So let's just start off where we know they fit together, right here, and then we'll go from there. Lovely. There we go. That's looking more scully than it was before. Excellent. Superb. So let's, just for good measure, put some along this seam. Actually, we probably want the other kind of glue that... Oh, this will be fine. That'll work. This is supposed to set up really fast, and that's okay. That should work. So we'll let that sit for a minute, and then we'll do the other side and get the other maxilla put on there. Yeah. Yeah. Anyhow. And, Eddie indeed says Pete Magyar. Yeah, I don't speak much, I don't speak any Hungarian. I don't understand or know much about that country or its language or people or anything. But from what I understand, what I do, the little that I do know, doesn't the name Pete Magyar sound a little generic? Isn't it kind of like, oh yeah, my name is Johnny America? Because Magyar is almost a synonym for the word Hungary, right? There's some dinosaurs from Hungary. One of them is Magyarosaurus. It's a little sauropod dinosaur, Magyarosaurus. It'd be like being an American named Peter American, yeah. Yeah. Magyarosaurus. Which basically means Hungarian reptile, right? Hungarian lizard. Yeah. Yeah, from Hot Dog Island, exactly. Yeah. Or Johnny English. There you go, Charlie's Dragon, yeah. Yeah. I like a name that delivers what it promises, you know? Someone even joked that he named the country after himself. There you go. Yeah. Anywho. This is looking pretty good right now. Well, almost. Here, I'll let that continue to sit for a minute and let that set up. I should have put a little bit of paper towel inside of there. In fact, maybe I'll still do that. Here's a little trick. You take some paper towel and you wet it a little bit. And then you put it in between something like this. It offers a little bit more strength to that bond. It gives the pieces of plastic something to adhere to. And it makes it more difficult for it to fall apart. I guess I didn't need to do it for this part. It's more over here. But we'll do that on the other side. Once this... No, here. We should do it here too. Yeah. Here we go. Now we know where the glue actually could be. We could put some more along here, and then we'll ensure a really strong bond.
But in the serious game of paleontology, much larger mysteries still remain.
Thank you. Mjolnir for the follow. Welcome to Paleontologizing. There we go. That should be better, I hope. A nice strong bond in there. It seems a little jury-rigged to be sticking strips of paper towel in there. But in the long run, I think that'll be really good. It's a fun little trick for when you're putting together big pieces of a 3D print like this. Nice. That's already setting up in just a few seconds, where earlier that was taking minutes and minutes for only a fraction of that strength. That's really good. Nice. Cool. And Petre Roman. It's really funny. That is funny, Eddie, indeed. Alright, nice. Let's do the other side. Again, I know this looks really kind of hokey, but it's going to help it stick a lot better. Having just something in between. Give both sides of this a little bit more purchase, a little bit more grip. There we go. that should fit on just like this. Beautiful. Nice. Lovely. Alright, now we got both maxillae on there with our 2 throws. Lovely, and I can feel good about that sticking together long term. That nice occlusion. Feels like it really wants to stay. Excellent. There we go. And this is a little off center, but that's fine. We can fix that later. Yeah. Superb. Very nice. Excellent. And look at... Oop, sitting on my keyboard. Not smart. Look at those 2 throws there. Lovely. Excellent. Lovely. Very nice. It's still moving around a little bit, but I think give it just a little bit more time. It should set up nicely. I'm going to put a little bit more glue here along this part. Hopefully that helps it to really stay together. There we go. Nice. I kind of forgot to wet the paper towel first too. But that'll be fine. Spray ball right here. Let's see if that helps. Cyanoacrylate or super glue. It often sets a little bit faster when it gets wet. Moisture helps, I think, catalyze it. But it is coming together, Golganek, absolutely. No, wait till we start putting these major pieces together. We've assembled the little bits into larger pieces. But man, when we start putting these larger pieces together, well, we're going to finish assembly today, so you'll see. You'll see. What's next here? I'll do the quadrates last. But the jugles... Okay. Jugles are going to go on to this assembly here. Well, hang on. Okay, the quadrates are what make it look like that. So we can ignore the quadrates for now, I think. Right? Do the quadrates need to go on? The quadrates kind of need to go on. Shoot. That's okay. I can print the hinge in 2 parts and then assemble it later and put like a sheath over the top of it to reinforce it. That'll be fine. Let's put the jugles on. Put the quadrates on, rather. That's right here. So the quadrate is the bone that attaches the skull to the lower jaw. So it is a critical piece. So we've got to make sure that this is really strong. Quadrates are right here. So they're going to fit on... This might be backwards. That. Oh, right quadrate is in here. That's our right quadrate, in our left quadrate. So let's go like this. The right quadrate is going to go on thusly, like that. Again, crucial part right here. So what I'm going to do is score this really quickly. Not really quickly, thoroughly. I want to make sure that this is nice and rough right here. Lots and lots and lots of good texture here, because this is one of those pieces where once I print and put on the lower jaw, this is a big potential point of failure. I want to make sure that this is really, really strong. Right, nice and rough. Same thing inside of that cavity. There we go. Do the same with our other one here. Just a few extra minutes of scoring like this could potentially save us hours of work later. So it's important stuff. Nice and rough. Excellent. Yeah. Go on here like this. Yeah. I want to make sure that we're also scoring this part over here too. These are feeling relative. Well, it's pretty good for the maxillae. I don't want to turn it over on its side yet. I don't want to stress it too much. Find a way to hold this without risking cutting myself. Score this part. There we go, looking good. This side over here. There we go. I know this is terrifically exciting to watch, but it is important to do. So bear with me for just a minute here. I think that's about good. There we go. Nice. All right, excellent. So I'm going to put on our quadrates. This is going to go right here, and this is not helpful because what angle am I supposed to put it on? Feels a little loosey-goosey. I guess it just kind of goes on like that. Huh. I think I might want to do the quadrates at the same time that I do the next step, because that'll help guide on where exactly it goes. So the jugles go on next. Let's do a little test fitting here. So I'm going to turn this over and trust that these parts are on properly. Feels okay. So our jugal goes on right here. Or sorry, quadrate goes on right here, and then there we go. There we go. So we use this part as a guide. Like that. Excellent. See, that is looking like a ceratopsian Jono. Excellent. Okay, I feel much more confident about that now. So, Gorilla Glue. Gorilla Glue. Gorilla Glue. Thanks for sticking with me as we Tetris this together. Don't want any overlapping overhanging flanges or anything like that, just like in Tetris. Make sure everything lines up beautifully. This is going to go on here like here. This is, again, our quadrate, where the lower jaw connects with the skull. And then here comes our jugal. It's on just like this. There we go. Lovely. Oh, beautiful. Nice. Very nice. Just got to hold this here while the glue sets up. And Eddie indeed says, I should print the dinosaur skeleton. My printer is not working enough for the filament that the filament dries. Are these STLs private, or can I find them on Discord? So these ones, you do have to purchase them for the Diabloceratops, but there's plenty of freely available dinosaurs that you can find across the internet. I would recommend Sketchfab and Thingiverse. Especially Sketchfab. Lots and lots of good stuff there. And you know what? I'm getting ahead of myself here. I got a little too excited. I should throw some wet paper towel on here. What am I doing? There we go. This one didn't even have any glue. What am I doing here? There we are. Sorry if that's a little gross, but it's doing what I can. Gotta make this work. Peg. I want it over here on the flat part. Over here. There we go. Now we can put this back on. I probably just saved myself a ton of headache right there. Making sure that the quadrate is all lined up properly. The jugal isn't going to come loose. I can already feel it setting up. This is great. Nice. I never thought of printing dinosaur skeletons like this. It's an excellent way to bring a dinosaur home, so to speak. There we go. Nice. That is already feels nice and solid. Excellent. I'll just let that sit for a minute. Just to be safe. Yeah. And then let me get some other strips of paper towel ready for the other side. It's beginning to tape shape. Yes, I think the rest of it is going to go together pretty quickly. I think you might be a little surprised at how quickly it comes together. Let me take this opportunity to score this part real quick. The other quadrate. Make sure that this is nice and textured. There we go. Very nice. Lovely. Oh, feeling nice and solid. Beautiful. All right, other side. So this is going to go on here like this. There's our other quadrate. But again, what angle do we put it on? We don't just want to feel it out. We'll use the jugal here as a guide. There we are. And I should probably score this side real quick too, just in case. Again, want to make sure that this is as robust as it could be. Grams prevention is worth a kilogram of cure, as we say in the sciences. We'll do this side too. Lovely. Okay. Quadrate here. Jugal. Here. Go. There we go. There we go. Nice. That'll work. Let's glue it up. And here too. There as well. This is excess. Ugh. All right. Stick some of this on here. Act as a nice kind of gap filler slash joiner. There we go. Okay. One go like this. And this right here. And then that right there. There we go. Come on now. Uh-oh. What fell over? I can worry about that in a minute. Do this now. I feel like something's failing. Something's not occluding properly anymore. What happened? What's going on here? No, it's just our lacrimal. Okay, that's fine. Lacrimal can fail, that'll be okay. But the rest of this is critical. We gotta make sure that this all fits together properly. There we go. We need more glue on there. Oops.
But when you find something like this, it may be something that's never been seen before.
May Turner, thank you for the follow. Welcome, welcome. There we go. There's that. We need some glue on here. Jugal. Help everything line up properly. Include nicely. There we go. That's exactly what I want to see. Beautiful. Okay. Lovely. Let's hold that together while it sets, and we can fix our lacrimal right there in a minute. And Eddie, indeed, I'm glad you like the coelacanth cookie cutter. That was a lot of fun to put together. I made coelacanth cookies last year for Fishmas. It's a special celebration that we do every December 22nd. 22nd or 23rd? I think it's the 22nd. It's to celebrate the discovery of the coelacanth. Latimeria cholumnae, December of 1938. It's a tradition here on this channel. Fishmas. Alright, there we go. There's our lacrimal. Lovely. Looking good. There you go, Alexander. Talk about tedium. I'm sorry this is boring. Shoot. I'm doing the best I can here. People wanted to see this assembled live on camera, so I'm doing my best to deliver that. I think it's going pretty well, all things considered. I'm gonna let that glue set for just a minute here. But yeah. Okay, Alexander. I get it. All good. Yeah. So, this step complete. We already did.
Do you think dinosaurs are put together correctly? The bones.
Oh, we're trying.
You're smart. What do you
question.
think?
Do a research on that, Oliver.
Kanari, thank you for the follow and welcome to Paleontologizing. It's good to have you here. Thanks for joining us. We've already done this, attaching the rostral to the, these are the premaxillae. It says maxilla here. I don't think that's entirely true. That's the premax. Anyway, we've already done this, the frontals and the prefrontals, brow horns. We already did the back of the skull, the frill, attached that. We already put the brain case onto there. And next up, yeah, we get to attach the beak to the jaws. You about ready for that? Let's do it. Here is our beak. Here's the front of our skull. Let's see what the best way to do this will be. And I am... Oh, goodness. This is so frustrating. The Vomer just does not want to stay. I think it needs some paper towel. This should do it. Third tries the charm, right? There we go. It just kind of needs something in between to help hold it together. That's our main issue there. And while that's setting up, the rest of this gets another minute to set too. It's not the worst. There we go. Yeah. Toilet roll. There you go, Cozy. This is paper towel here, or I guess what folks in a Commonwealth country might call kitchen roll. But here in the States, we call it paper towel. But yeah. But no, we do use a lot of paper towels. And toilet paper. Loo roll. Bog roll. Toilet tissue. We do use a lot of that in the field and in the lab. It's useful stuff. Man, this Vomer is really... temperamental. I might just worry about that later. Let's stick this on though. Maybe this will help it stay. Here we go. Lovely. Oh, that's beautiful. Very nice. Phenomenal. That is excellent. Beautiful. Okay. I'm gonna score this a little bit, this surface, rough that up. Give it a better shot of actually adhering properly. There we go. Nice. Nice and rough right there. Blade is coming out. Stay in there. It's getting so dull. But that's okay. I've got others. I might as well continue to use the dull one because we don't need it to be particularly sharp for this. That's good enough. Alright. Put glue on here and on here. And then on... There's these surfaces too. There we go. Looking good. Hang on. Huh. The Prius is done. Excellent. We'll go check on that in a minute. I just heard the 3D printer finishing up. Okay. Put some wet paper towel on there. Just to give it a little bit more something to adhere to. There we go. Just a little spritz on each of these. Here we go. Lovely. Looking good. Superb. That is nice. That's really nice. It's coming together. We're running out of pieces. We just have this, the face, or the front of the face, and now the back of the face and the frill. One more connection, and I think we're done after that. Holy cow. Yeah, big old hawk's beak. Yeah, it's a big beaky animal. It's got quite a set of chompers. You would not want to get bitten by this critter. It'll bite you in half. Big beaks on ceratopsid dinosaurs. People talk about the horns being formidable. The beak is maybe even more formidable on this animal. Very nice. Here, while that's setting up, let's go take a look at my car. Not too shabby. There's still supports on it, which carefully remove. I gotta be really careful not to snap these wing mirrors off. But, yeah. Nice. This is what I'll be driving to Utah tomorrow. Not... The actual one is over... parked here at the house. Yeah. This will be nice. I can paint it up just like the real thing. It'll be fun. Lovely. Yeah. Right now, this is... It's feeling pretty good. Testing it a little bit. It's still a little unsure of itself. Do is hit it with a little bit more glue between the lacrimals and go. I want to make sure it's nice and centered on there. Good. Looking good. Nice. I don't know why it wants to naturally go off-center. I'm trying to hold it. Where it's supposed to be. Lovely. Oh boy. This won't even... Tricky. There we go. It's going to go on there like that. I think I know what I have to do. We're going to have to bring in another table in here, so hang on just a minute. There we go. Running out of space in here. There we go. There we go, like that. Okay. This is going to be tricky, but we can do it. Especially with this, there's... It was really tempting to put these big parietal horns on toward the beginning, and I'm realizing now that was not the smartest move, because they take up a lot of space. And they make maneuvering difficult. Probably should have done that last, but it's impressive with them on there. And I wanted to do that early on, because I thought it would be really cool looking, and it was. Carving away some of this to make it a little bit easier to put together. measuring since it looks almost complete. We're getting there, we're getting there. Score this on the 2. It's going to be an important surface. Let's do it. I'm gonna have to kind of hug this to my chest, I think, for a minute. Just to get it on there. Ready? Let's do it. Final assembly. Multiple pieces that all have to fit together perfectly right here. So far, so good. I gotta squeeze together those. There we go. Okay. Chin. I can't see what's going on the other side, so hopefully everything is together. Looking at the camera, it looks a little loose. Right here by this side. There we go, that's better. Looking good. There's like a bunch of different points of contact that all have to be together at the same time. But the most crucial is probably right here. So I'm trying to hold that. There we go, something shifted. That's much better. Okay, good, good, good. Good, 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 good. All right, stay together, stay together. Nice, okay. Oh man, superb. It's working. I'm really trying to hold the nose on right here, because that's kind of our toughest spot. The two pieces under the brow horns really want to separate along the sagittal plane there, and so I'm trying to keep them from doing that. And if I go like this, it'll help. There we go. Oh, no. That's not what I was trying to do. Gosh darn it. Put that back. Again, this is like a 2 or 3 person job. But it's just me doing this, so I gotta make it work. There we go. Nice. Skull bones and their numerous pieces. Yeah, skull's not a one bone thing. There's many bones that make up the skull. And if you take nothing else away from this part of the stream, let it be that. Skulls are complex. It's a lot of pieces. We are looking pretty good here. I gotta say, could be doing a lot worse. Could be doing a lot worse. Lovely. What I kind of want to do here is just... Where's a way to like keep pressure on this? If I had a giant rubber band, I could put it through here and just cinch this part down. But I don't have that. So we'll just keep this here for another couple minutes. Let that glue really start to set. And then we'll be golden. Very nice. Lovely. Moon Pie, what are you doing? Moon Pie's like, me? What are you doing? Oh, and there she goes. She's walking out the door again. She's like, I don't want any part of this. Sorry, Moon Pie. Looking good. Oh man. It's funny, Diabloceratops, I don't think of it as having a particularly large skull. But clearly, it's a lot bigger than mine. Like it's a sizable animal. Not nearly one of the biggest of the ceratopsids, but still, it's a substantial critter. I'm gonna put a little bit more glue in here. If I can find it. There it is. And then hopefully this helps it set up a little bit faster. Especially if I wet it a little bit. There we go. That's what we want to see. I can already see the cyanoacrylate changing color, drying a little bit. This is good. This is really good. Yeah. Is that Windex? It's mostly water, but there's a little bit of what is it? It's called Steramine. It's like sanitizing spray. I don't have a spray bottle with just plain water in here, so that's the closest I got. It's what's at hand. And it is like 99% water, so looking good. Looking very good. Excellent. Just a few more minutes of this. I know this is thrilling to watch right now, but I really got to hold this together in order for it to set properly. So that's what we're doing. Flash Gordon, interesting. Yeah. Would Triceratops, if it had been allowed to continue to evolve, would its descendants have also have had solid frills That's a good question. Yeah. There is some evidence that Triceratops may have fenestrated late in ontogeny, especially earlier on in the Maastrichtian. But that is heavily debated. It's the sort of thing that ceratopsian workers argue about to no end. We'll probably do a stream about that at some point. Ceratopsian phylogeny, and different lineages evolving in different directions, and all that, but I gotta ask Denver Fowler if he want to sit down with me and do a special stream about that at some point, because I think that'd be a ton of fun. Yeah. Trouble with that, it just does not want to occlude right there. I'm going to put a little bit more paper towel on the inside. We're going to have to force this a little bit. Something for the glue to adhere to. There's a big old gap. I'm not super confident with it being that way. So here's my quick and dirty way to fix it. There we go. Of this, we can wrap up the stream. My earbud's already yelling at me. Bluetooth one, it's gonna die pretty soon. Go. Okay, there we go. Now or never. It's working. There we are. That's what I wanted to see. That glue is setting up, it's soaking into the paper towel, it's sticking to the other side. That gap is not insurmountable anymore. It's setting up. Good, 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 good. Love to see it. Right. Beautiful. Nice. And Flash Gordon, oh, there's a number of different extinction events that dinosaurs suffered throughout the Mesozoic, like major extinction events. The Cretaceous, or the Jurassic Cretaceous boundary is subject to a big extinction event. We lose most of the big North American dinosaurs, the Diplodocids, the Allosaurids, the Ceratosaurs, the Stegosaurs. They all go out at the end of the Jurassic, and the more we look at it, the more it seems like it was a sudden thing. Jim Kirkland's got a really good talk about it. If one of the mods wants to pull this up, actually. It's on YouTube. Search, I think, Dino Decimation. Jim just gave this talk, I think at UFOP, Utah Friends of Paleontology, just a few months ago. But this is a cutting-edge thing in dinosaur evolution. He's currently working on a paper about this, I think with Mike Benton, if I remember correctly. Or maybe that was... maybe Mike's not an author, I forget. But anyway. And it seems to be a thing not just in North America, but in Europe and Asia, too. Or at least in North America and Asia, I don't know about Europe. where a bunch of those late Jurassic dinosaurs just disappear suddenly at the end of the Jurassic. And there's a decent chance that there may have been a major event that happened, like a huge volcanic eruption and/or an asteroid strike. There's a crater in South Africa, the Morokweng crater, that seems to date to this time. So it sounds kind of far-fetched, but evidence seems to point so far to there being an asteroid impact at the end of the Jurassic, which may have in turn triggered massive volcanic eruptions, and that may have actually been what causes such a big change between the end of the Jurassic and the beginning of the Cretaceous. It's neat stuff. So yeah. And Flash Gordon, they like their cycads. Well, the cycads don't really... Well, here, I'll put it this way. The angiosperms don't even, like, show up in the fossil record until the early Cretaceous. I think about 130 million years ago. So there's like a 15 million year gap in between the end of the Jurassic, when this extinction event took place, and then the rise of the angiosperms. So anyway, it's interesting stuff. We're still kind of in really early days when it comes to this. But, I'm excited to see what the next few decades will hold in terms of people trying to tackle this problem. And, yeah. See stuff. And the Cretaceous was a totally different global climate compared to the Jurassic. It does start off with like this period of extreme wetness during the Berriasian stage at the very beginning of the Cretaceous. Almost on the scale of like the Carnian pluvial episode back in the Triassic. And again, this is all like brand new stuff. And this is looking good. But yeah. Okay, I think I'm comfortable leaving that there right now. Ooh. Past those parietal horns. Yeah. But yeah, check that out. You ready? Oh, ah! Diabloceratops. Holy cow. I am stoked about this. I'm gonna go set this down and let it continue to set. Hopefully I've got enough space I can get out of the office here. God. Alright, sorry for bonking you there, chat.
8, we have the Tradoon. Tradoon.
Thank you, Broncond, for the prime there. Really appreciate that.
Get back to South Utah. Tradoon.
And I'm going to North Utah, actually, Salt Lake. Oh, at some point I will probably get back to South Utah, back to St. George and surrounding areas. Anywho, I'm leaving for Utah first thing tomorrow morning. Let's go to a wedding near Salt Lake. So I've really got to finish packing my things and final preparations. So now is when I will bid you adieu, chat. Don't go away just yet. We're going to raid into somebody else doing some science here on Twitch. There we go. Let's see if Rhacodactylus is on, given that it is Wednesday when he does science outreach. There he is. Yeah. Rhacodactylus. There we go. We didn't even really get a chance to talk about Deinonychus today, but we will put a Deinonychus under our credits here. I guess we have to refresh the cache there for the credits to show up. There we go. Thank you, everybody, for joining us today. Thank you to all those new followers. Ton of them who came in with the Kit Boga raid. Really appreciate that. Thank you, everybody who followed. You raiders, really appreciate the opportunity to talk about fossil science with you, to talk about natural history, to talk about evolution and the history of life on our incredible planet Earth. Thank you to everybody who followed, and I hope to see you again next week. I should be streaming on Tuesday. Probably not Monday, it should be Tuesday. I think I want to take it easy, take 2 days to drive back to California from Utah. Thank you to the subscribers and the resubscribers, the people who make these streams possible through their financial contributions. Could not do this without you. Thank you for your support. Thank you once again to our wonderful moderation team. Mods, thank you so much for keeping this a safe and welcoming community for everybody. We're running out of time. Hang on, wait, no. No, we're not running out of time. Wrong timer. We're going to go right into Rhacodactylus, who, like me, is a scientist who streams here on Twitch. He's a cognitive scientist, studies why people believe weird things, from internet hoaxes and rumors to conspiracy theories and kind of everything in between. He does excellent science outreach here on this platform, and I'm